Come with me on a journey. This isn't a trip measured in miles or kilometers, but in the steady, relentless march of light across the cosmos. It's a journey into an empire of silence, a kingdom of quiet that dominates the universe in a way we're only just beginning to comprehend. For most of human history, we've looked up at the night sky and wondered what fills the darkness between the stars. We spent centuries charting those pinpricks of light, discovering they are suns, much like our own, just impossibly far away. Then, we learned they're gathered into immense star cities we call galaxies. Welcome to the science for deep sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. But tonight, our journey takes us beyond that familiar glow. We aren't traveling to the light, but to the darkness. We're seeking the spaces between the great cities of the cosmos. What happens when you leave the glittering spiral arms of a galaxy behind? What lies in the profound, crushing emptiness that separates one island of stars from the next? We're about to venture into the heart of the great nothing, the cosmic voids, to uncover the hidden architecture of everything that is and everything that isn't. This is Science for Sleep, an exploration of the largest, quietest, and most mysterious structures in existence. Imagine the deepest, most absolute blackness you can conjure in your mind. A perfect void. Now, stretch that blackness. Stretch it past the edges of your room, past the moon, past the furthest planet in our solar system. Keep stretching it, across a distance so vast that a beam of light traveling at nearly 300,000 kilometers every single second would need 100 million years just to cross it. That's the scale of the quietest place in the universe. It's a place where there is, for all intents and purposes, nothing. But this nothingness isn't an absence. It's a presence. It is the dominant feature of our universe, and it holds the deepest secrets of our cosmic past and our ultimate fate. Our cosmic address, setting the stage. To really understand the scale of this emptiness, we first have to ground ourselves in a place we know. Our journey begins at home, on a small, blue-green world, orbiting an unremarkable star, in a quiet suburban spiral arm of a galaxy we call the Milky Way. Our planet is one of 8, a collection of rock, gas, and ice held captive by the gentle, persistent gravity of our sun. Our solar system is a cozy, bustling neighborhood, but it's just one household on a single street in a sprawling celestial city. That city is our galaxy, the Milky Way. It's a magnificent, barred spiral of perhaps 200 billion stars, maybe even more. From one edge to the other, it measures about 100,000 light-years across. A formidable distance, to be sure. Even if you could travel at the speed of light, it would take you 100 millennia to cross from one side to the other. Our sun is nestled about 2/3 of the way out from the galactic center, far from the chaotic energies of the supermassive black hole at its core. This is our city. And for a long time, we thought it might be the only one. But as our telescopes grew more powerful, we began to see smudges of light in the darkness, fuzzy patches that weren't single stars. They were other galaxies, other cities of stars, each as grand and complex as our own. And they weren't scattered randomly. Like human settlements, they tend to gather together. Our Milky Way is no hermit. It's part of a small, intimate gathering of galaxies known as the local group. Think of it as our local town. The local group contains more than 50 galaxies, though most are small, faint dwarf galaxies, like suburbs clinging to the larger metropolises. The two dominant members, the two major cities in our county, are our own Milky Way and the slightly larger Andromeda galaxy. Andromeda is our closest major galactic neighbor, currently about 2.5 million light-years away, and closing. The third largest member, the Triangulum galaxy, is a smaller spiral, a respectable town in its own right. This collection, our local group, spans about 10 million light-years of space. It's our immediate cosmic family, bound together by mutual gravitational attraction. We're all on a long, slow, cosmic dance. For a time, this seemed like the grandest scale of organization. A universe dotted with these galactic towns and cities. But we were only just beginning to grasp the true hierarchy of the cosmos. Our journey outward had barely begun. We had mapped our town, but we were about to discover the existence of states, countries, and entire continents. The Great Galactic Cities. Understanding Galaxy Clusters. As we pull our perspective back even further, the local group itself begins to look small. We see that it's not an isolated town, but merely a suburb, a quiet outlying district of a much vaster structure. We're on the very edge of the Virgo supercluster, a colossal collection containing thousands of galaxies. And at the heart of this supercluster lies its dense urban core, the Virgo cluster. This is the next level of cosmic structure. A galaxy cluster is a true megalopolis of the universe. Where our local group is a town of about 50 galaxies, a rich cluster like the Coma cluster, located about 320 million light-years away, contains over 1,000 galaxies packed into a roughly spherical region just 20 million light-years across. These are the gravitational centers of the universe, the great cities where matter has been collecting for billions of years. The space inside these clusters is far from empty. While the galaxies themselves are the most visible residents, they're swimming in an extraordinary medium. Between the galaxies, in the vast intracluster space, is a sea of incredibly hot gas. This is the intracluster medium, or ICM. It's a tenuous plasma, heated to temperatures of 10 to 100 million degrees Kelvin, even hotter than the core of our Sun. At these extreme temperatures, the gas glows brightly, not in visible light, but in X-rays. When we point our X-ray telescopes at a distant galaxy cluster, we don't just see the individual points of light from the galaxies, we see the entire volume of the cluster glowing with a ghostly, ethereal haze. In fact, the total mass of this superheated gas in a cluster often outweighs the combined mass of all the stars in all of its thousands of galaxies. But even this incredible amount of gas isn't enough. When astronomers measured the speeds of galaxies orbiting within these clusters, they found a profound problem. The galaxies were moving too fast. Based on all the visible matter, the stars, the gas, the dust, the cluster's gravitational pull shouldn't have been strong enough to hold onto them. The clusters should have flown apart, their member galaxies scattering into the cosmos like dandelion seeds in the wind. There had to be something else there. Something invisible, something that didn't shine or reflect light, but which exerted an immense gravitational force. This invisible glue, this unseen scaffolding holding the cosmic cities together, is what we call dark matter. It's the true majority shareholder in these galactic metropolises. In a typical galaxy cluster, dark matter accounts for an astonishing 80 to 90% of the total mass. The brilliant galaxies and the superheated gas, all of it is just a luminous froth on a deep, invisible ocean of dark matter. These clusters are the most massive, gravitationally bound objects in the universe, great islands of light, gas, and an overwhelming presence of darkness. Examples like the Perseus and Coma clusters are testaments to this structure. They are monuments of gravity's patient work over eons, pulling together thousands of galaxies into dense, dazzling, and violent environments where galaxies can collide, merge, and be stripped of their gas as they plunge through the hot intracluster medium. For a long time, we thought the story of the universe was the story of these great cities. But we were wrong. The most important story, the one that defines the very character of our cosmos, is the story of the space between them. The cosmic web. The hidden architecture of the universe. Having journeyed through the dense, brilliant cities of galaxy clusters, we now turn our gaze to the vast expanses that separate them. What connects the Virgo cluster to the Coma cluster? What lies between great superclusters like our own, Laniakea, and its distant neighbors? The answer is one of the most beautiful and profound discoveries in modern cosmology, the cosmic web. The universe, on its largest scales, isn't a uniform scattering of galactic islands in a formless sea. Instead, it has a definite structure, a breathtaking architecture that resembles a sponge or a spider's web spun across the entirety of space. This cosmic web is the skeleton of the universe, and it's made of two primary elements, filaments and voids. The filaments are the threads of the web. These are long, sinuous structures of dark matter, stretching for hundreds of millions of light years, linking the great galaxy clusters together. Traced along these filaments, like beads on a string, are countless galaxies and smaller galaxy groups. The filaments act as cosmic highways, funneling gas and galaxies from the sparser regions of space towards the massive clusters that sit at the intersections, the dense nodes of the web. If galaxy clusters are the great cities, then the filaments are the interstellar interstates, the bustling trade routes along which the commerce of the cosmos flows. They're rivers of matter, both dark and luminous, flowing steadily towards the deepest gravitational wells. But if the filaments are the threads, then the most dominant feature of the cosmic web is what lies between them. These are the cosmic voids. They are the vast, dark, empty bubbles that the filaments surround. These aren't just small gaps, they are colossal regions of underdensity, spanning from tens of millions to hundreds of millions of light years across. While the filaments and clusters contain the vast majority of the galaxies, the voids contain the vast majority of the volume. They're the countryside, the great wildernesses, the silent oceans of the cosmos. In fact, these empty spaces make up more than 80% of the volume of the entire observable universe. Our universe is not mostly full of things, it is mostly full of nothing. This incredible structure wasn't created by chance. It's the inevitable result of gravity acting over cosmic time. The story of the cosmic web begins just after the Big Bang, nearly 13.8 billion years ago. In the primordial soup of the early universe, matter and energy were distributed with almost perfect uniformity. But there were tiny, quantum fluctuations, minuscule variations in density from one place to another. Some regions were infinitesimally denser than average, and some were infinitesimally emptier. Over billions of years, gravity went to work. The slightly denser regions had more gravity, so they pulled in matter from their surroundings, becoming even denser. It was a runaway process. The rich got richer. These regions grew into the dark matter halos that would eventually seed the formation of galaxies, clusters, and the great filaments of the cosmic web. At the same time, the regions that started out slightly less dense lost matter to their richer neighbors. They became even emptier. The poor got poorer. These regions expanded and merged, ballooning into the colossal, serene emptiness of the cosmic voids. The cosmic web is, therefore, a fossil. It's a snapshot of the initial conditions of the universe, amplified by gravity over the entire age of time. It is the grand and beautiful architecture that emerged from the simplest of beginnings. And now, it's time for us to leave the safety of the filaments and venture into the heart of one of these great voids. A journey into the void, the great nothing. Prepare yourself. We're now leaving the cosmic web's bright filaments behind. The river of galaxies thins out, the background hum of gravity fades. We're crossing the shore and entering the silent ocean. Welcome to a cosmic void. The first thing that strikes you is the scale. It's a scale that defies human intuition, a size so profound that our minds struggle to find a handhold. Let's try an analogy. If our entire Milky Way galaxy, with its hundreds of billions of stars and its 100,000 light-year diameter, were shrunk down to the size of a single grain of sand, a typical large void would be the size of a vast sports stadium. A stadium filled with almost nothing. Perhaps the most famous of these structures is the Boötes Void, sometimes called the Great Nothing. Its discovery in 1981 was a moment of profound shock for astronomers. A team led by Robert Kirshner was mapping the universe in 3 dimensions by measuring the redshifts of galaxies. As they surveyed a patch of sky in the direction of the constellation Boötes, the herdsmen, they found something deeply unsettling. A gap, a colossal region of space where the galaxies simply stopped. As they mapped its boundaries, the sheer size of the void became apparent. It was a roughly spherical region of space, a staggering 330 million light-years in diameter. Based on the average density of galaxies in the universe, a volume that large should contain thousands of galaxies. Kirshner's team initially found only 8. Today, after decades of more sensitive surveys, that number has been revised upwards to merely 60 or so galaxies. 60 galaxies in a space that should hold thousands. It's the cosmic equivalent of searching the entire North American continent and finding only a handful of small villages. The astronomer Greg Aldering famously put this scale into perspective. If the Milky Way had been in the center of the Boötes void, we wouldn't have known there were other galaxies until the 1960s. Think about that. For all of human history, up until just a few generations ago, we would have looked out into the night sky and seen only the stars of our own galaxy. The vast darkness beyond would have been absolute, offering no hint that other cosmic islands even existed. The discovery of the universe beyond our own galaxy, one of the most transformative moments in human thought, was only possible because we live in a relatively dense neighborhood. But our journey doesn't end with a visit to a distant void. There's a controversial but fascinating idea that we may, in fact, live inside one. It's called the KBC Void, named for astronomers Ryan Keenan, Amy Barger, and Lennox Cowie, who studied it in 2013. Their work suggested that our local patch of the universe is significantly less dense than the cosmic average. The proposed void is enormous, perhaps 2 billion light-years in diameter, making it one of the largest ever hypothesized. Is it real? The idea remains highly debated in the scientific community. Some recent data suggests the underdensity might be smaller or shallower than first thought, but the very possibility reframes our place in the universe. We may not be residents of a bustling cosmic city after all, but inhabitants of a quiet, isolated island in the middle of a great cosmic ocean. So what does it truly mean for a void to be empty? It's not a perfect vacuum. If you were to float in the center of the Boötes void, you wouldn't be in total blackness. You'd still see the distant glow of the cosmic web, the walls of the void, as a faint, shimmering tapestry in all directions. The space is still filled with the cosmic microwave background radiation, the faint afterglow of the Big Bang.
Stray photons and neutrinos, born in distant stars and supernovae, stream through the void constantly. And there's still dark matter, just at a much, much lower density than elsewhere. Even the few galaxies that exist within voids are fascinating laboratories for understanding how galaxies evolve in isolation, far from the violent interactions of a crowded cluster. The void is not empty of everything, but it is empty of structure. It's a place where gravity has lost the war. It's a place of profound and enduring peace. The deeper mysteries, voids and the fate of the universe. These great cosmic voids are more than just curiosities of cosmic geography. They are central to the deepest and most challenging mysteries in all of cosmology. They aren't passive bystanders in the universe's evolution, they are active participants, and their very existence is a powerful clue to the nature of reality itself. One of the greatest mysteries is the accelerating expansion of the universe. In the late 1990s, astronomers discovered that not only is the universe expanding, but that expansion is speeding up. Some strange, repulsive force is pushing everything apart. We call this force dark energy. We don't know what it is, but we can see its effects everywhere. And the cosmic voids are where its effects are most powerful. Think of it this way: inside a galaxy or a galaxy cluster, gravity is king. The density of matter is high, and its attractive force easily overwhelms the gentle push of dark energy. But inside a cosmic void, there is very little matter. Gravity is weak. In these vast regions of emptiness, dark energy is the dominant force. And so, it is the voids themselves that are expanding. They are actively growing, pushing against the filaments of the cosmic web, stretching the space between the galaxy clusters further and further apart. The accelerated expansion of the universe isn't happening everywhere equally. It's happening primarily in the voids. They are the engines of cosmic expansion, slowly and inexorably pulling the cosmic web apart. Voids may also hold the key to solving the Hubble tension. This is one of the most pressing crises in modern cosmology. We have two primary methods for measuring the expansion rate of the universe, and they give different answers. One method, looking at the early universe, predicts a slower expansion than the other method, which measures the expansion in the local, modern universe. The controversial KBC void offers a tantalizing potential solution. If we are living inside a massive underdensity, the gravitational pull from the denser regions outside the void would make nearby galaxies appear to be moving away from us faster than the true cosmic average. Our cosmic address could be biasing our measurements. While the debate is fierce and far from over, it highlights how these great voids can have a direct impact on our understanding of the entire cosmos. Finally, there's the mystery of the CMB cold spot. In the map of the cosmic microwave background, there is a region of the sky that is unusually large and cold. One leading hypothesis connects it to another colossal void, the Eridanus supervoid. This is an immense underdensity, perhaps over 1 billion light-years across, located in the same direction as the cold spot. The theory suggests that as photons from the Big Bang's afterglow pass through such a massive void, they lose a tiny amount of energy, making them appear slightly colder to us. While current models suggest the void alone can't explain the full temperature of the cold spot, the correlation is too strong to be a coincidence, confirming a causal link between the two. The great voids are not just empty spaces, they are windows into the fundamental physics of our world. Our journey is now drawing to a close. We have traveled from the comfort of our solar system, past the magnificent spiral of the Milky Way, beyond our local group, and through the great, glittering cities of the galaxy clusters. We journeyed along the filaments of the cosmic web and plunged into the silent, expansive heart of the cosmic voids. We have stood in the center of the great nothing, a place of such profound emptiness it challenges our very definition of the universe. We've learned that this emptiness isn't an absence, but the dominant feature of our cosmos, the hidden architecture that dictates its past and its future. These voids are not just gaps. They are the battlegrounds where gravity and dark energy wage a war for the fate of the universe. They are the laboratories where we can probe the deepest cosmic mysteries. The universe is not the brilliantly crowded tapestry of light we often imagine. It's a far more delicate and subtle structure. It's a cosmic foam, a gossamer web spun across an ocean of near nothingness. The light is the exception. The silence is the rule. The next time you look up at the night sky, at the scattered diamonds of light on black velvet, remember the velvet. Remember that the true story of the universe is written in that darkness. It is a story of beautiful, magnificent, and essential emptiness. Sleep on that. If you've enjoyed this journey into the quiet corners of the cosmos, consider following for more explorations of the science that shapes our universe. Every question we answer only leads to a dozen more, and the journey of discovery is one that never truly ends. Part 2: What a galaxy cluster really is. If you could drift far enough away from the Milky Way, far beyond its spiral arms, far beyond the quiet companionship of Andromeda, and keep going until even entire galaxies started to look like faint lanterns scattered across a dark sea, you would begin to notice something strange. The universe, on its largest scales, is not arranged like a smooth mist. It is not evenly sprinkled, like dust across a table. It gathers. It leans inward. It builds neighborhoods, then cities, then something even larger and more patient than cities. And one of the grandest of those structures is the galaxy cluster. At first, the phrase sounds simple enough. A cluster of galaxies. Just a collection. Just a crowd. But the truth is much more beautiful than that, and much more immense. A galaxy cluster is not merely a place where galaxies happen to be near one another. It is a deep gravitational landscape. It is an environment. A kingdom of matter held together over unimaginable stretches of time. It is a place where galaxies do not simply exist side by side, but influence one another, shape one another, and slowly change under the weight of a shared cosmic home. Tonight, let's slow down and stay with that idea for a while. Not the empty spaces between the clusters just yet, but the clusters themselves. What they are. How large they really are. What fills them. What holds them together? And why, when astronomers look at them, they are not just seeing many galaxies in one place, but some of the largest bound structures the universe has ever made. The easiest place to begin is with something familiar. A single galaxy, like the Milky Way, already feels enormous to us. It contains hundreds of billions of stars, clouds of gas and dust, dark matter, star clusters, black holes, and long stretches of apparently quiet space. Even light, racing at its cosmic speed limit, would need about 100,000 years to cross our galaxy from one side to the other. That alone is almost too large to picture. So when we talk about something bigger than a galaxy, the mind has to start letting go of its normal habits. Now picture not one galaxy, but dozens, then hundreds, then in some cases, more than 1,000, all gathered into the same general region of space. Not touching, not piled up like marbles in a bowl, but held in a giant invisible structure by gravity. That is the first real step toward understanding a galaxy cluster. It is not a solid object. It is not dense in the human sense. There is still an enormous amount of emptiness between one galaxy and the next. But on cosmic scales, those galaxies belong to the same system. They are linked by gravity the way planets belong to a solar system, even though the distances involved are so vast that the comparison almost feels unfair. This is where it helps to separate a few terms that are easy to blur together. A galaxy is one city of stars. A galaxy group is a relatively small gathering of galaxies, like a local neighborhood. Our own Milky Way belongs to one of these smaller associations, the local group. That includes the Milky Way, Andromeda, Triangulum, and many smaller dwarf galaxies. A cluster is much larger and more massive. If a group is a town, then a cluster is a metropolitan region, with gravity acting as the infrastructure that keeps the whole thing from drifting apart. This difference matters, because a cluster is not just more galaxies. It is a different kind of environment. The local group, quiet as it is, still gives galaxies room to remain themselves for long periods. But in a rich galaxy cluster, galaxies live in a busier, harsher place. Their motions are faster. Their encounters are more frequent. Their gas can be stripped away. Their shapes can be altered. To enter a galaxy cluster is to enter a place where gravity has been doing patient, relentless work for billions of years. One of the gentlest mistakes the mind makes when thinking about a cluster is to imagine it as something crowded. That is only because our instincts were built for rooms, roads, and cities on Earth. In reality, even inside a rich galaxy cluster, the galaxies are separated by huge distances. If one galaxy were a firefly floating in a dark valley, the next might be another firefly far, far away, with miles of silence between them. And yet, compared with the rest of the universe, that still counts as crowded. This is one of the recurring lessons of cosmology. The scales are so extreme that a place can be mostly empty and still be considered densely populated. A typical galaxy cluster may span several million light-years. Some are larger still. Within that volume, galaxies orbit through a shared gravitational well at speeds that can reach thousands of kilometers per second. They are not stationary. They are moving, circling, falling, crossing paths over spans of time so long that a single orbit can take billions of years. The cluster is alive with motion, but it is motion so slow and spacious that no human eye could ever watch it directly. You would need the patience of the universe itself to see it unfold. And here is where the story becomes even more interesting. If galaxies were all a cluster contained, that would already be enough to inspire awe. But galaxies are only the most visible residents. They are the bright islands, the easy landmarks. The true body of a cluster is much stranger. Between the galaxies there is gas. Not thick gas, not clouds you could see with human eyes, but an extremely thin plasma spread across the cluster. This gas is so hot, heated by gravitational collapse and violent motion, that it reaches tens of millions of degrees. It is not glowing in visible light. It shines in X-rays. This means that when astronomers observe galaxy clusters with X-ray telescopes, they do not just see separate galaxies. They see the cluster itself, bathed in a ghostly halo of hot intracluster gas, like an invisible ocean suddenly made visible. That detail is worth lingering on, because it changes the mental picture entirely. A galaxy cluster is not just galaxies drifting in darkness. It is galaxies moving through a vast, superheated medium. Every large galaxy in the cluster is like a ship crossing an almost impossibly thin but still real cosmic sea. Over time, that sea matters. It can push against galaxies, strip gas from them, and slowly affect their ability to form new stars. In other words, the environment of the cluster can change the fate of the galaxies inside it. This helps explain something astronomers noticed long ago. In many rich clusters, especially near their centers, galaxies tend to be older, redder, and less active in star formation. There are many giant elliptical galaxies there, swollen and smooth, not as rich in cold gas as youthful spiral galaxies like the Milky Way. It is as if the cluster environment encourages a kind of aging, not in a sudden dramatic way, but in a long, quiet one. A galaxy entering a cluster may slowly lose the raw material needed to make new stars. Over immense timescales, the bright blue signs of youth begin to fade, and the cluster becomes full of older stellar populations. So already, a cluster is more than a gathering. It is a place where galaxies live under different rules. But even this still does not bring us to the deepest truth of what a cluster is, because the galaxies and the hot gas, impressive as they are, account for only part of the story. The real skeleton of the cluster is hidden. Astronomers began to suspect this many decades ago when they measured how fast galaxies were moving inside clusters. The numbers did not make sense. Based only on the visible mass, the galaxies were moving too fast. There was not enough gravity from stars and gas alone to hold the cluster together. By all appearances, the system should have flown apart long ago. And yet it had not. So there had to be more mass present than the eye could see. A great deal more. This unseen mass is what we call dark matter. It does not shine. It does not reflect light. It does not reveal itself the way stars do. But it has gravity, and on the scale of galaxy clusters, that gravity dominates. Most of the mass in a cluster is not in the galaxies, not in the stars, not even in the hot gas. It is in the dark matter halo that surrounds and binds the entire system. That means when we look at a galaxy cluster, the luminous galaxies are almost like decorations hanging on a much larger invisible structure. They are the candles on a chandelier whose full frame we cannot see directly. The cluster exists because dark matter built the well, gravity deepened it, gas fell inward, galaxies gathered, and the entire structure matured over cosmic time. There is something strangely peaceful about that picture. We often think of the visible universe as the main story. Stars, galaxies, nebulae, brilliant explosions. But clusters remind us that much of reality is hidden. The grandest structures we can observe are, in a sense, guided by something we do not yet fully understand. The visible universe is only the surface expression of a deeper architecture. One of the most famous examples of this comes from systems like the Bullet Cluster, where two galaxy clusters have passed through one another. In such observations, astronomers can map where the hot gas is, where the galaxies are, and where most of the mass appears to be based on gravitational lensing, the bending of light by gravity. The result is astonishing. The ordinary matter and the dominant gravitational mass do not perfectly line up. It is one of the clearest signs we have that most of the mass is indeed something separate from the bright, visible material. Even in collision, the hidden framework reveals itself by the way gravity shapes the light passing through it. And collisions do happen, not the way stars collide in every direction, because the galaxies are still very far apart, but entire clusters can merge over billions of years. When they do, it is among the most energetic events since the Big Bang. Hot gas crashes into hot gas. Shock waves ripple through intracluster space. Dark matter halos pass and overlap. Galaxies continue onward, sometimes only lightly disturbed, while the gas, which is more collisional, behaves differently. These mergers are slow by human standards and violent by cosmic ones. A cluster, then, is not always a settled city. Sometimes it is a construction site. Sometimes it is a battlefield. Sometimes it is an ancient capital that still carries the scars of how it was assembled. If we visit real examples, the picture becomes even richer. The Virgo cluster, relatively nearby on cosmic scales, is one of the major structures in our broader region of the universe. It contains thousands of galaxies and plays a central role in the gravitational landscape around us. The Coma cluster, farther away, is a classic rich cluster, dense and full of large elliptical galaxies. The Perseus cluster is famous not only for its scale, but for the strange and beautiful structure seen in its hot gas, shaped in part by the activity of a supermassive black hole at the center of one of its galaxies. These are not just distant collections of dots. They are cosmic ecosystems, each with its own history. And perhaps that word, ecosystem, is one of the best ways to think about a galaxy cluster without becoming too technical. Because a cluster is a place where many components coexist and interact. Galaxies move through a common gravitational field. Gas fills the space between them. Dark matter provides the unseen structure. Black holes in central galaxies can pump energy into surrounding gas. Smaller groups fall into larger clusters. Stars age. New stars become rarer in some environments. The whole thing evolves. Slowly, majestically, and with a scale that almost defeats the imagination. There is also a subtle emotional shift that happens when you truly picture a cluster. A single galaxy still feels, in some distant way, relatable. It has arms, a center, stars, worlds perhaps. It resembles a city, and cities we understand. But a cluster does not feel human at all. It feels geological, meteorological, like a continent of gravity, or a weather system built from galaxies instead of clouds. That is closer to what a cluster really is. Not a machine, not a pile, but a gravitational landscape within which other cosmic objects live out their lives. And once you see it that way, another truth becomes clear. The universe is not mostly made of isolated things. It is shaped by relationships. A galaxy is one structure, yes, but its fate also depends on where it lives. A spiral galaxy in a quieter group can keep forming stars for long ages. A galaxy deep in a massive cluster may be stripped, heated, stirred, and transformed. Place matters. Context matters. Even on the largest scales we can imagine, nothing exists entirely alone. That idea has a way of softening the mind. It reminds us that the cosmos is not random light scattered in empty dark. It has memory. It has architecture. It has regions where gravity has spent billions of years arranging matter into patterns that only now, after all this time, we are beginning to recognize. A galaxy cluster is one of those patterns. A place where the universe became organized enough to create not just one island of stars, but whole nations of them, suspended inside an invisible sea. If you find yourself enjoying this slow journey out into the larger structures of the cosmos, you can quietly leave a like, subscribe if you want to stay for the next stages of the voyage, and maybe share in the comments where in the world you're listening from tonight. It is always a gentle reminder that while we are speaking about unimaginable distances, this experience still begins in one small room, on one small planet, with one curious human mind. And perhaps that is the most remarkable contrast of all. Here we are, tiny and temporary, trying to understand systems millions of light years across, most of whose mass we cannot see, whose motions unfold over billions of years, and yet somehow the mind can still reach toward them. Not fully hold them, perhaps, but reach toward them. So when someone asks what a galaxy cluster really is, the simplest answer is still true. It is a giant gathering of galaxies bound together by gravity. But the fuller answer is more satisfying. A galaxy cluster is a deep well in the cosmic landscape, built mostly by dark matter, filled with hot gas, populated by galaxies, shaped by mergers, and matured over immense ages. It is one of the universe's great cities, though even city is too small a word. It is a continent of matter. A crossroads in the cosmic web, a place where the visible and invisible parts of the universe meet, and understanding that changes the way the night sky feels. Because the distant points of light we see from Earth are not just isolated beacons. Some of them belong to galaxies that belong to groups, which belong to clusters, which belong to something even larger still. The universe is layered, nested, structured. One scale opening into another, then another, then another. In the next part of this journey, that is exactly where we will keep going. We have lingered inside the great galactic cities. We have let our eyes adjust to their size, their hidden mass, and their slow internal weather. But soon we will begin to pull back again. And once we do, an even stranger realization waits for us. Because as immense as galaxy clusters are, the spaces between them are larger still. For now, though, let the cluster remain in your mind as a quiet image. Not as a diagram or a statistic, but as a place. A place of drifting galaxies, invisible gravity, hot silent gas, and time so deep it almost becomes still. A place where matter gathered, stayed, and became part of something greater than any one galaxy could ever be on its own. And somewhere in that thought, there is a certain calm. The sense that the universe is not only vast, but organized. Not only silent, but structured. Not only full of light, but held together by unseen foundations. Sleep with that for a while. Let your mind drift there, into one of the great cosmic cities, and rest among galaxies. Part 3, From Galaxies to Superclusters. Now that the idea of a galaxy cluster is resting quietly in the mind, we can do something that always changes the way the universe feels. We can pull back again. That is one of the strangest habits astronomy teaches us. Every time you think you have reached a scale so large it must surely be enough, the cosmos asks you to step farther back. The Milky Way once seemed impossibly vast. Then it became one galaxy among many. A galaxy cluster seems almost too grand to absorb, and yet even a cluster is not the end of the story. It belongs to something larger. And that larger thing belongs to something larger still. So for a little while, let's leave behind the close-up view and simply widen the frame. Imagine standing on a hill above a city at night. At first, your attention is drawn to individual lights. A building, a road, a bridge. Then, slowly, the pattern begins to appear. Neighborhoods gather around one another. Highways connect distant districts. Downtown rises more densely than the outskirts. The city is no longer a collection of separate points. It becomes a structure. The universe is like that, only on scales so large that even the word structure begins to feel fragile. A galaxy, as we've already seen, is a vast city of stars. Billions of suns, clouds of gas, dark matter, dust, black holes, and perhaps countless worlds, all bound together in a shared gravitational home. Some galaxies are graceful spirals, like the Milky Way. Some are smooth ellipticals, older and calmer in appearance. Some are small and irregular, shaped more by circumstance than symmetry. On its own, a galaxy feels like a complete thing, a finished work. But galaxies do not usually live alone. Our own Milky Way, for all its size, is part of a much smaller gathering called the local group. This is the first step upward in scale, and it is an important one because it helps the mind build a ladder rather than trying to leap all at once. The local group is not a cluster. It is more intimate than that. It contains the Milky Way, Andromeda, the Triangulum Galaxy, and many dozens of smaller dwarf galaxies, all spread across a region of roughly 10 million light-years. That already sounds enormous, and it is. But compared with a true galaxy cluster, it is still modest. A town, perhaps. A loose collection. A gravitational family rather than a metropolis. This is where it becomes useful to slow down and make clean distinctions, because the language of the cosmos can blur if we rush. A galaxy is one great island of stars. A galaxy group is a relatively small association of galaxies, gently bound together. A galaxy cluster is much larger, more crowded, more massive, and more dominated by the common environment created by its gravity, gas, and dark matter halo. And then, beyond even the cluster, there is the supercluster. The name sounds dramatic, almost like something invented just to impress, but it is simply another rung on the ladder. A supercluster is a vast region where galaxy groups and galaxy clusters are arranged together in a broader pattern, not packed into one spherical object the way galaxies sit within a cluster, but connected across immense distances, often along the great filaments of the cosmic web. This is one of the places where our ordinary instincts begin to fail us. When we hear the word cluster, we imagine something gathered tightly. When we hear supercluster, we may imagine the same thing, just larger. But the reality is subtler than that. A supercluster is not always a single compact object. It is more like a sprawling province of the universe, containing many clusters, groups, and filaments, all related within one enormous gravitational landscape. So if a galaxy is a city, and a galaxy cluster is a major urban region, then a supercluster is something like an entire continental system, with cities, towns, highways, and huge stretches of less populated terrain between them. Even that comparison is too small, but it helps. Our own cosmic neighborhood is part of a much larger structure called Laniakea, a name that means immense heaven. It is one of those rare scientific names that feels almost poetic without trying too hard. Laniakea is not a single cluster. It is a supercluster scale region containing many galaxy groups and clusters, including the Virgo cluster and our own local group, all participating in a larger pattern of motion and gravitational relationship. To say we live in the local group is true. To say the local group lies on the outskirts of the Virgo region is also true. To say all of this belongs to Laniakea is true again. The universe is nested this way. One structure inside another, one level of belonging opening into the next. There is something calming about that idea if you let it settle properly. The cosmos is not just a random splash of matter. It has layers, context, membership. Even our galaxy has an address. And yet, if we keep widening the frame, even superclusters do not remain the final answer. They begin to look less like isolated giant objects and more like knots in a far larger web. This is where the universe stops resembling a collection of things and starts resembling a pattern. Astronomers did not discover this all at once. The picture emerged slowly, over time, as galaxy surveys improved. When telescopes could finally map large numbers of galaxies across vast distances, the result was deeply striking. Galaxies were not spread uniformly in all directions. They gathered into filaments, clusters, walls, and sheets, with giant emptier regions between them. What appeared from one scale to be the whole arrangement turned out, from a larger scale, to be just one part of a wider architecture. The cosmic web is the name we give to this architecture. It is one of the most important ideas in modern cosmology, not because it is flashy, but because it tells us what the universe is really like on its largest scales. Galaxy clusters sit at the intersections of this web, like glowing cities at major crossroads. Filaments stretch between them, carrying galaxies and gas along their lengths. And between these filaments lie the great underdense regions, the voids, the vast quiet zones that occupy most of the universe's volume. That is why understanding the difference between galaxies, clusters, and superclusters matters so much. Without that ladder of scale, the space between galaxy clusters has no emotional meaning. It is just an abstract phrase. But once you feel the hierarchy, once you understand how large each rung already is, then the emptiness between them becomes something almost eerie in its size. Let's stay on the ladder a little longer. Suppose you begin with the Milky Way, a galaxy about 100,000 light-years across. Already, that is far beyond human comprehension in any everyday sense. Then you rise to the local group, spanning around 10 million light-years. Already, the galaxy has become one member of a larger family. Then you step up to a cluster like Virgo, where thousands of galaxies gather in a region many millions of light-years across. The scale stretches again. Then to a supercluster like Laniakea, where multiple groups and clusters take their places inside a still broader flow of matter. At each step, what felt central becomes local. What felt ultimate becomes provincial. And that repeated decentering may be one of the deepest lessons science offers. Every level of structure teaches humility. Every wider frame reminds us that reality is built from relationships far larger than the ones that first seem obvious. There is another important difference between these scales, and it has to do with how tightly they are bound. A galaxy is strongly bound by gravity. Its stars orbit within a common dark matter halo. A galaxy group is also gravitationally bound. A cluster, too, is a deep gravitational system. But superclusters are more complicated. Some parts of them may be bound and flowing toward common attractors, while other parts participate more in the general expansion of the universe. This is one reason the edges of superclusters are not always simple or sharp. They are not solid objects. They are broad territories defined by motion, density, and connection. That can sound abstract at first, but it helps to imagine weather patterns over a continent. There may be clear centers of pressure, rivers feeding into basins, winds moving across open land, and boundaries that are not walls, but transitions. A supercluster is somewhat like that. Not a lump, but a region of coordinated cosmic geography. And what makes this even more fascinating is that all of it grew from tiny differences in the early universe. Long ago, when the universe was young and matter was distributed far more evenly than it is now, there were still slight variations from place to place. Some regions had just a little more matter than average. Some had a little less. Gravity worked on those differences over billions of years. The slightly denser regions pulled in more material and became denser still. The slightly emptier regions lost material and became emptier still. Over immense spans of time, these tiny early ripples developed into galaxies, groups, clusters, filaments, and voids. So the ladder we are climbing now, galaxy, group, cluster, supercluster, web, is really the visible outcome of ancient asymmetries, amplified patiently by gravity. There is a kind of elegance in that. The largest structures in existence began as tiny differences. The universe did not need to start with giant shapes already formed. It only needed slight unevenness, a little time, and the slow persistence of gravity. Sometimes, when people first hear about these scales, they imagine that space is filled almost everywhere with galaxies, and that clusters are simply places where there are more of them. But the truth is more extreme than that. Most galaxies are not scattered evenly across a cosmic background. They belong to this network. They follow the web. They gather where gravity has made it easiest for matter to collect. In that sense, clusters and superclusters are not exceptions. They are the natural consequence of the universe organizing itself. And once you realize that, the next question almost asks itself. If the galaxies follow filaments, and clusters sit at the crossroads, then what exactly lies between the crossroads? How empty are the open spaces between the web's brightest concentrations? That question is coming. But before we go there, it helps to dwell for a moment on the emotional reality of this scale ladder, because it changes how everything else lands. A single galaxy can still feel personal. It can contain stars like the Sun, planets like Earth, perhaps beings asking questions of their own. A cluster begins to feel less personal and more architectural. A supercluster is larger still, almost geographical. And the cosmic web feels like the universe itself is no longer made of objects, but of tension and spacing, of crowded regions and silent ones, of threads and hollows. It is as though the universe has a skeleton, not a solid frame, but a lacework, a foam, a pattern of concentration surrounded by absence. And where are we within that lacework? On a small planet, around an ordinary star, in one spiral galaxy, inside one local group, near the margins of larger structures, in a universe that keeps unfolding outward no matter how many times we think we have reached the edge of useful scale. If this kind of calm unfolding of the cosmos is helping you relax tonight, you can gently leave a like, subscribe if you want more slow journeys like this one, and maybe share in the comments where you're listening from. It's always a quiet pleasure to imagine these thoughts traveling out into bedrooms, cities, coastal towns, mountain villages, and sleepless corners of the world, while above all of us the same layered universe waits in silence. One of the reasons this part of cosmology is so powerful for sleep-friendly storytelling is that it moves in exactly the way the mind drifts when it is settling down. It does not leap. It expands. One idea leads to the next. One circle widens into another. And slowly, almost without noticing, you are no longer thinking in human distances at all. That may be why these scales feel both soothing and unsettling. They remove urgency from ordinary concerns, but they also dissolve the comfort of small boundaries. The Milky Way is not the whole stage. The local group is not the whole stage. Virgo is not the whole stage. Laniakea is not the whole stage. Every frame is part of a larger frame. Every home belongs to a larger neighborhood. Even the word neighborhood becomes funny eventually. What is a neighborhood when the roads are filaments of galaxies and the empty lots are millions of light years across? But the mind still needs metaphors. It still needs little bridges from the familiar into the impossible. So we build them carefully, knowing they will fail, but also knowing they are the only way to begin. Another useful way to picture the difference between these scales is through social closeness. Within a galaxy, stars are part of a common stellar system. In a group, galaxies are like familiar neighbors, relatively near one another on cosmic terms. In a cluster, the gathering is bigger, busier, and more dominated by the shared environment than by any one member. In a supercluster, the sense of common identity becomes looser, broader, and more structural. The members are connected less by intimacy and more by belonging to the same immense terrain. That distinction matters because when we talk about the space between galaxy clusters, we are not talking about a simple gap between two isolated balls. We are talking about separations within this wider network, where the universe's matter is very unevenly arranged. Some regions are rich and busy. Others are astonishingly sparse. The scale of those sparse regions only becomes meaningful once you know what they are sparse relative to. And they are sparse relative to galaxies, groups, clusters, and superclusters. Sparse relative to the brightest knots in the web. Sparse relative to the places where matter gathered successfully over billions of years. You might say that a galaxy cluster is what happens when gravity wins decisively in one place. A supercluster is what happens when many such victories align along a broader terrain, and the spaces between them are where gravity has not won in the same way at all. There is also a beautiful shift in perspective hidden in this. Most of us grow up imagining space as mostly stars, because stars are what we can see with our eyes. But the large-scale universe is not defined primarily by stars. It is defined by distribution, by density, by where matter gathered and where it thinned out. The visible lights are only the brightest expressions of a much bigger pattern. That pattern is what cosmology studies when it asks the largest possible questions. Not just what objects exist, but how the universe arranged them. Not just what galaxies are made of, but why they live where they do. Not just how far things are from us, but how the whole cosmic map is organized. And when you let those questions settle into a gentler tempo, they become almost meditative. What is a galaxy? A city of stars. What is a cluster? A gathering of galaxies shaped by gravity. What is a supercluster? A broader province of clusters, groups, and filaments woven into the web. And what is the web? The largest visible architecture of matter across the universe. Each answer opens rather than closes the mystery. Because after building this ladder, the silence between its highest rungs becomes impossible to ignore. We have spent so much of human history looking toward the luminous parts of the cosmos, toward the stars, the galaxies, the clusters, the places where matter made itself obvious. But the deeper story may lie just as much in what is missing, in what did not gather. In the regions left thin and dark as the richer parts became richer still. That is where we are heading next. But before we leave this part behind, let the hierarchy settle in softly. A galaxy is not alone. A group is not the final gathering. A cluster is not the largest structure. A supercluster is not a single object so much as a vast terrain within the cosmic web. And the web itself is not a full fabric, but a delicate arrangement of crowded threads stretched across enormous volumes of quiet. That is the scale of the universe we actually inhabit. Not an even field of galaxies, but a layered architecture of belonging and separation. And maybe that is the most important thing to carry forward from this part. The universe is not just big. It is organized big. It has levels. It has shape. It has regions that gather and regions that open outward. Once you understand that, even a phrase like, the space between galaxy clusters, starts to feel heavier, deeper, and stranger. Because now you know what those clusters are. You know where they sit. And you know they are only the bright intersections in a much larger design. So let your thoughts drift outward one more step. Past the Milky Way. Past the local group. Past Virgo. Past the supercluster scale, until the web itself begins to appear, thin and luminous, suspended over a darkness that is no longer just background, but the main stage. And there, in that immense hush between the great concentrations of matter, the real question begins. How large are those spaces, really? Part 4. Measuring the space between galaxy clusters. How far apart are the great cities of the universe? It sounds like such a simple question at first, almost childlike in the best possible way. If a galaxy cluster is one of the cosmos's great gathering places, then how much distance lies between one cluster and the next? How much darkness do you have to cross after leaving one immense concentration of galaxies before another one finally appears ahead of you? And the answer, when it begins to settle in, has a very particular effect on the mind. It does not just sound large. It sounds quiet. It sounds stretched. It sounds like time itself thinning out into distance. Because the space between galaxy clusters is not measured in anything that feels human. Not in miles. Not in kilometers. Not even in the kind of distances we use for the solar system. You cannot really approach it with the instincts you use for cities, countries, oceans, or even planets. To understand these separations, you have to let go of ordinary distance almost completely. You have to let the universe teach you a new scale of patience. So in this part, let's do exactly that. Let's not rush into the deepest voids just yet. Let's first learn how astronomers think about the space between clusters, what units they use, why there is no single neat answer, and what these distances actually feel like once you stop treating them as numbers and begin treating them as stretches of reality. Because that is the key, really. A number alone is not enough. A distance only becomes meaningful when the imagination can rest inside it for a moment. The problem begins with the fact that the universe is built in layers of scale that quickly outgrow our language. The Earth feels large when you are crossing it. The Moon feels far away. The Sun is farther still. Pluto, even in its quiet exile, is vastly farther than that. The nearest star beyond the Sun is so far that even its light takes more than 4 years to reach us. Then the Milky Way stretches to about 100,000 light-years across. Already, by that point, the mind is on very thin ice. It keeps nodding as though it understands, but it is mostly being polite. And then you move outward again. The gap between galaxies can be measured in hundreds of thousands or millions of light-years. The gap between groups and clusters becomes larger still. And the space between major clusters, especially when they are separated by the emptier regions of the cosmic web, can extend across tens of millions, and sometimes well over 100 million, light-years. That is where the phrase, between galaxy clusters, stops feeling like a small gap and starts feeling like a domain. It helps, as always, to begin with the unit itself. A light-year is not a measure of time, even though it sounds like one. It is a measure of distance. It is the distance light travels in 1 year, moving at nearly 300,000 kilometers every second. That works out to about 9.46 trillion kilometers. Even saying that number aloud does not truly help much, because trillion is already too big for the imagination to wear comfortably. But the principle matters. A light year is not chosen because it is dramatic. It is chosen because space is so large that ordinary units become clumsy almost immediately. If you tried to talk about galaxy clusters in kilometers, the numbers would become ridiculous so quickly that the meaning would disappear. It would be like describing the size of an ocean in raindrops. Technically possible, perhaps, but not useful. So astronomers use light years, and often millions of light years, because the cosmos demands broader containers for thought. Sometimes they also use another unit called the parsec, and on larger scales the megaparsec. But for our purposes tonight, there is no need to get tangled in that. The calmer, more intuitive road is simply to stay with light years and let them widen gradually in the mind. 1 light year, then 1,000, then 1 million, then 10 million, then 100 million. This is the rhythm of the universe on its largest scales. Now, one important thing needs to be said early, because it saves a lot of confusion. There is no single standard distance between galaxy clusters. The universe is not laid out like a neat grid. Clusters are not arranged at equal intervals, like streetlights on a road. They live within the cosmic web, where some regions are richer in matter, some are poorer, some clusters are connected by filaments, and some are separated by broader, emptier zones. So when we ask how much space lies between clusters, we are really asking about a range of distances within a very uneven architecture. Some clusters are relatively near one another in cosmic terms, linked along filaments of the web. Others are separated by much broader expanses, especially where voids open up between the denser regions. So the answer is not one number. It is a family of scales. Tens of millions of light years is common on the larger structural level. Greater separations are not unusual once you widen the map enough. And that, in a quiet way, is already astonishing. Because even a single million light-years is such an enormous distance that it almost swallows the meaning of travel. If you were moving at the speed of light itself, the fastest speed we know nature allows, 1 million light-years would still take 1 million years to cross. Not days. Not centuries. 1 million years. And the separations we are talking about between clusters are often many times larger than that. A beam of light leaving one cluster and heading toward another might be in flight for tens of millions of years before arriving. Entire species could rise and vanish on one small planet while that light is still on its way. Mountains could form and wear away. Oceans could shift. Ice ages could come and go. And still the light would be crossing the silence between the great concentrations of matter. That is one way to begin feeling the scale. Not as a number, but as a duration. Another way is to compare the levels of cosmic structure we have already climbed. The Milky Way is about 100,000 light-years across. Our local group spans roughly 10 million light-years. A rich cluster can occupy a region several million light-years wide. And then the spaces between the great clusters, the open separations in the web, can run far beyond that. In other words, the gap between major structures can be far larger than the structures themselves. That is important. The empty stage is bigger than the actors on it. It is one of the most consistent truths in cosmology. Whatever luminous thing you are looking at, the surrounding silence is usually larger. At this point, it can be tempting to imagine the universe as a scattered field of isolated spheres, but that still misses the deeper reality. Clusters do not merely sit in blank space at random. They sit at nodes in the cosmic web. Filaments stretch between some of them. Groups and galaxies flow along those filaments over immense timescales. So when astronomers speak about the space between clusters, they are often also thinking about where in the web that space lies. Is it a relatively populated bridge of matter? Is it a thin region with only a few scattered galaxies? Or is it part of a vast underdense zone, a true cosmic emptiness compared with the crowded intersections? This is why the word empty in cosmology is often a little misleading. It does not usually mean absolutely nothing. It means very little, compared with what lies elsewhere. Still, even very little on these scales can be extraordinary. Now you might wonder how astronomers measure such immense distances in the first place. After all, no one can lay a ruler across the cosmic web. No spacecraft has traveled from one cluster to the next. The answer is that distance in astronomy is built from light, motion, and patience. For nearby stars, astronomers can use geometry, measuring the tiny apparent shift of a star as Earth moves around the Sun. But galaxy clusters are far beyond that method's comfortable reach. For larger distances, astronomers rely on what is sometimes called the cosmic distance ladder. Certain kinds of stars and exploding stars have known brightness patterns, so by comparing how bright they truly are with how bright they appear, astronomers can estimate how far away they must be. Beyond that, for the largest scales, the expansion of the universe becomes part of the story. Light from distant galaxies is stretched as space expands, shifting toward the red end of the spectrum. The more stretched it is, generally speaking, the farther away the source is. That redshift becomes one of the great measuring tools of cosmology. It allows astronomers not only to estimate distances, but to build three-dimensional maps of the universe. A galaxy is not just seen on the sky. Its distance can also be estimated. The same goes for groups, clusters, and entire large-scale structures. And when enough of those points are mapped, the hidden architecture begins to appear. Filaments, walls, clusters, voids, the web. There is something beautiful about that method when you think about it quietly. We do not step outside the universe to map it. We learn its structure by reading its light, by noticing how brightness fades, how color shifts, how gravity bends what passes through it. The universe does not hand us a chart. It gives us clues. And from those clues we have learned that the spaces between clusters are among the great defining features of the cosmos. If this slow unfolding of scale is helping you settle into the night, you can gently leave a like, subscribe if you want to keep traveling outward with me, and maybe leave a comment sharing where in the world you're listening from. There is something quietly lovely about that contrast, people in ordinary rooms, under ordinary roofs, listening to distances so immense they make continents feel like dust. Now, let's move from the unit to the feeling. Suppose you were somehow able to leave a galaxy cluster behind. You would pass outward through the cluster's outskirts, where galaxies become less common, where the hot intracluster gas thins, where the common gravitational grip becomes less intense. Depending on the cluster and its environment, you might enter a filament, a long thread of galaxies and matter connecting one large structure to another. Or you might begin to move into a more open region. In either case, what would define the journey is not what you see, but how little changes from moment to moment. That is one of the difficult things about cosmic scale. We often imagine large journeys as full of scenery. But on the largest scales, immense travel can look almost static. You could move for millions of light years and still be surrounded mostly by darkness, with only the distant arrangement of galaxies shifting slowly over unimaginable spans. The scale is so large that even change becomes rare. This is why the space between clusters is not merely big. It is stretched in a way that changes the meaning of movement itself. On Earth, travel usually means approaching things. A mountain grows larger. A city skyline rises. A coastline appears. In intercluster space, there may be almost nothing to approach for immense durations. The destination exists, yes, but the journey is dominated by absence. That is one reason these distances feel so haunting once you picture them properly. They are not just long, they are unbroken. And because the universe is expanding, the story becomes even subtler. Clusters are not only separated by great distances. On large enough scales, the space between distant structures is itself changing. The fabric of the universe stretches. Galaxies not bound tightly together drift farther apart over time. So in some cases, these separations are not fixed roads. They are widening gulfs. That means the great spaces between clusters are not passive background. They are part of the living evolution of the cosmos. The map itself changes. This can sound abstract, but think of it as a kind of cosmic breathing, except not the calm inhale and exhale of something that returns to its starting point. More like a slow, one-way loosening. The grand structures remain, but the larger fabric between them is carried outward. The open regions become more dominant. The distances grow. And perhaps that is why learning the scale of intercluster space changes the emotional tone of the universe. It is one thing to know that galaxies are far apart. It is another to realize that even the great collections of galaxies, the clusters, are themselves isolated by vast reaches of darkness. The universe does not simply contain emptiness. It is organized around emptiness. This is easier to feel with a small mental experiment. Take everything you know from ordinary life and keep shrinking it. Shrink roads to lines. Shrink cities to points. Shrink continents to specks. Then spread those specks over a field so huge that the points barely matter compared with the open ground between them. That is closer, in spirit at least, to the structure of the large-scale universe. The bright places matter deeply, of course. They are where stars form, galaxies evolve, and beings like us can arise. But in terms of sheer volume, the quiet places win. The universe gives most of its room to separation. There is a calm kind of honesty in that. We often imagine importance belonging to where things are. But cosmology keeps reminding us that the space where almost nothing is happening still dominates the picture. The background is the main stage. And this is why measuring the distance between clusters matters so much. It is not just a matter of statistics. It is a way of discovering what kind of universe we actually inhabit. Not a crowded one, not a packed celestial city, but a sparse and delicate architecture, where matter gathers into bright knots and long strands, leaving immense expanses in between. Once that begins to sink in, another question rises naturally. If the space between clusters is so vast, what is it like physically? Is it a perfect vacuum? Is it truly nothing? Or does something subtle still remain there, too thin to notice at first glance, but still part of the story? That question is where we are heading soon, and it is one of the most satisfying turns in the whole journey. Because the universe is rarely as empty as it first appears, even in its emptiest places. But before we go there, stay with the scale a little longer. Imagine a light signal leaving one cluster and beginning its trip across tens of millions of light years. It travels faster than anything else can travel. Faster than planets orbit, faster than galaxies drift, faster than anything human technology has ever approached. Yet the trip still takes longer than human civilization has existed by a factor so large it becomes absurd. If you replaced light with one of our spacecraft, the journey would become so long that the age of the universe itself would feel like a practical obstacle. This is not a road that could ever be crossed casually. It is not even a journey in the ordinary science fiction sense. It is an abyss of duration. And yet the universe contains countless such stretches. There is also a subtle emotional twist hidden here. We often think of distance as something that isolates, and in one sense it does. But on cosmic scales, distance also reveals pattern. The fact that clusters are separated by such vast spaces makes their arrangement more meaningful, not less. It is because the distances are so large that the filaments and nodes of the cosmic web stand out. The emptiness is what makes the structure visible. A spider's web does not impress because the silk is thick. It impresses because the silk stretches across open air. In the same way, the cosmic web is beautiful because its threads and intersections span enormous quiet volumes. The space between clusters is part of the design. Without it, there would be no large-scale pattern to admire. And maybe that is a comforting thought to carry into sleep, that even emptiness can have shape. Even silence can belong to a structure. Even absence can be part of how the universe holds itself together. So what have we really learned here? We have learned that the space between galaxy clusters is not a single fixed number, but a range of vast separations shaped by the cosmic web. We have learned that these distances are usually measured in millions, and often tens of millions, of light years. We have learned that ordinary units collapse under such scale, which is why astronomy lets light itself become the ruler. We have learned that the journey across such space is defined less by landmarks than by extraordinary stretches of quiet. And we have learned that these separations are not incidental. They are part of the very architecture of the universe. Galaxy clusters are not placed side by side. They are islands in a larger geography. Great cities separated by darkness so immense that even light needs ages to cross it. And once you truly feel that, the next question becomes almost irresistible. If the gulf is that large, what is actually in it? For now, let the scale settle softly. Let the numbers fade, but keep the feeling. The sense of leaving one great concentration of matter and traveling outward into a darkness so extended that time itself begins to feel like distance. The sense that the universe is made not only of what gathers, but of what opens. Not only of stars and galaxies, but of room. Unimaginable room. That room is where we are going next. And in that next stretch of the journey, the emptiness will become stranger than it first seems. Because even the quiet between galaxy clusters is not quite as empty as the word empty suggests. Part 5. Is the space between galaxy clusters truly empty? After spending time with the scale of the distances, with those immense dark reaches stretching between one galaxy cluster and the next, it becomes almost natural to think of those regions as pure nothingness. Just emptiness. A perfect absence. A place where the universe forgot to put anything at all. And in one sense, that feeling is understandable. If you leave behind the crowded heart of a galaxy cluster, if you drift away from its thousands of galaxies and its hot, glowing intracluster gas, and if you keep traveling outward through tens of millions of light years of darkness, then yes, what surrounds you would feel empty in a way that almost nothing in ordinary life ever does. There would be no nearby stars lighting your path, no planets, no dust clouds glowing softly in visible light, no familiar constellations hanging above a landscape, just distance, just blackness, just the long silence between the universe's brighter gatherings. But the deeper truth, as is so often the case in cosmology, is gentler and stranger than the first impression. The space between galaxy clusters is not truly empty. It is not crowded, not busy, not rich in matter the way galaxies and clusters are. But neither is it a perfect void in the absolute sense. It contains things, very faint things, very thin things, things spread so widely that they nearly disappear into the darkness, and yet they are still there, still part of the story, still participating in the larger architecture of the cosmos. And somehow that makes the universe feel even more beautiful. Because once again, reality turns out not to be divided into simple opposites, not full versus empty, not something versus nothing, but into gradients, thick regions and thin regions, bright places and dim ones, dense knots and delicate stretches. The intercluster spaces are part of that continuum. They are the quiet places, yes, but quiet is not the same as absent. So tonight, let's rest in that question for a while. What does emptiness actually mean on a cosmic scale? What remains in the darkness between the great clusters? What would you find if you could drift through it patiently enough? And why do astronomers sometimes learn the most from places that seem, at first glance, almost empty at all? The first thing to understand is that a perfect vacuum is more of an ideal than a common reality. Even in places that seem astonishingly empty, the universe tends to leave traces of itself behind. A few atoms here, a few photons there, a faint field, a whisper of radiation. Matter spread so thinly that it would be meaningless in ordinary human terms, yet still present in the ledger of the cosmos. If you took the emptiest artificial vacuum humans have ever created in a laboratory, it would still not really compete with the great emptiness between cosmic structures. Space between clusters is vastly thinner than anything we can comfortably imagine on Earth. And yet, even there, it is not literally nothing. For one thing, there is gas. Not clouds like the glowing nebulae inside galaxies. Not the thick, cold gas that collapses into new stars. Something much more diffuse. Much more stretched out. The space between clusters can contain extremely thin intergalactic gas, often made mostly of hydrogen, the simplest and most abundant element in the universe. Hydrogen is, in a sense, the quiet background ingredient of cosmic existence. One proton, one electron. Simple, ancient, and nearly everywhere. In the spaces between galaxy clusters, this gas is often so sparse that you could travel enormous distances before encountering even a small amount of it by everyday standards. A few particles in a cubic meter might already count as something meaningful there, sometimes less. The numbers are so tiny compared with the air we breathe that any earthly comparison almost becomes absurd. The room around you right now, even if it feels still and empty, is flooded with molecules. Intercluster space is not like that. It is far more rarefied than silence. And yet rarefied is not the same as absent. This faint intergalactic gas matters because it tells us something important about the universe. Matter did not all end up inside stars. Not all of it went into galaxies. Not all of it gathered into the bright structures we naturally focus on. A great deal remained diffuse, stretched along filaments, scattered through the broader web, or lingering in the open regions between the denser nodes. Some of this matter has a name that sounds technical at first, but the idea behind it is surprisingly simple. Astronomers speak of the warm hot intergalactic medium, often shortened to WIM. It is one of the places where some of the universe's ordinary matter seems to hide. Not hidden in the sense of magical or mysterious like dark matter, but hidden because it is so thin, so hot, and so difficult to detect directly. This gas can run along large-scale filaments and in the broader stretches between major cosmic structures, heated over time by shocks and gravitational motion. That phrase, warm hot intergalactic medium, may sound a little dry, but what it really means is that even the dim spaces between the universe's brighter places are not dead still. They have a thermal history. They have been stirred, stretched, and heated by the slow work of cosmic evolution. The universe does not only sculpt its dense regions, it leaves fingerprints in its sparse ones too. And then there is light. Or perhaps it is better to say radiation, because not all of it would be visible to human eyes. One of the easiest mistakes to make when picturing intercluster space is to imagine total blackness, as though light itself simply ends between the clusters. But light crosses those vast regions constantly. Photons born in stars, galaxies, quasars, and other distant processes stream through the darkness all the time. They may be few and far between compared with the flood of light near a star, but they are there. Most gentle of all is the cosmic microwave background, the ancient afterglow of the early universe. It fills all of space. Not just galaxies. Not just clusters. Everywhere. Even in the emptiest regions you can imagine, the universe is still bathed in this faint relic radiation, a quiet remnant from when the cosmos was young, hot, and much more uniform than it is now. That may be one of the most soothing facts in all of astronomy. No matter how far into emptiness you travel, you never entirely leave the universe's beginning behind. The afterglow remains. A soft, nearly uniform whisper from a time long before galaxies existed. Even the greatest cosmic loneliness is still wrapped in the oldest light of all. There are also neutrinos, those ghostly particles that pass through matter with astonishing ease. Trillions of them move through your body every second without notice, and they pass through the emptiest regions of space just as silently. There are cosmic rays too, high-energy particles launched by energetic events in the universe, traveling long distances through intergalactic space. There may be faint magnetic fields stretched across large scales, subtle and difficult to map, but still part of the cosmic environment. None of these things fill space in the way air fills a room, but together they remind us that emptiness in the universe is layered, not absolute. Even gravity is there, of course. Gravity reaches across the silence. The spaces between clusters are not beyond influence. They are shaped by the pull of surrounding matter, by the deep wells of galaxy clusters, by the larger geometry of the cosmic web, and by the slow expansion of the universe itself. In fact, one of the oddest and most beautiful things about intercluster space is that what happens there is often defined by what is not there. Because there is less matter in those regions, gravity competes differently with expansion. The thinner the matter, the weaker the local pull. The quieter the region, the more the broader expansion of the cosmos can assert itself. So even what feels like emptiness has a kind of physics, a kind of character. It is not merely an absence of objects. It is an environment. That may be the most important shift in perspective this part can offer. The space between galaxy clusters is not just a blank gap separating important things. It is itself a cosmic setting, with its own density, its own ingredients, its own role in the evolution of the universe. And once you begin to see it that way, the darkness becomes less empty and more subtle. There is another reason the space between clusters is not truly empty, and it has to do with dark matter. Although dark matter does not gather uniformly either, and although its density is much lower in some regions than in clusters or filaments, it still contributes to the large-scale structure of the universe. The bright parts of the cosmic web, the galaxies and clusters, formed where matter, especially dark matter, accumulated most strongly. But that does not mean the surrounding regions are completely free of it. Rather, they contain much less of it. Enough to matter gravitationally, but not enough to build the same luminous architecture. This distinction between nothing and less than average is crucial. Much of cosmology depends on learning to think in terms of density contrasts rather than absolute categories. A void is not usually a place with no matter whatsoever. It is a place with much less matter than the cosmic average. Likewise, the space between clusters is often not a perfect absence. It is underdense compared with the clusters themselves. Thin, not null. Sparse, not void of all existence. Human language is not always built for that kind of subtlety. We like clean categories. Full or empty. Present or absent. But the universe prefers gradients. And in a strange way, those gradients are more restful to think about. They make the cosmos feel less like a machine made of sharp edges and more like a landscape of changing texture. If you were somehow drifting through one of these enormous intercluster stretches, what would you actually notice? The honest answer is, not much, at least not in any immediate sensory way. The darkness would dominate your experience. Galaxies would still exist in the distance, but they would be remote, faint, and sparse. The nearest major structures might take millions of years for light to cross. There would be no nearby sun to warm you, no sky in the ordinary sense, no horizon, no atmosphere, no color except the occasional far-off glow of distant galaxies and the invisible sea of background radiation all around. But physically, you would still be inside something. Inside the universe's diffuse medium. Inside expanding spacetime. Inside a field of faint particles, low densities, weak radiation, and long-reaching forces. It would feel empty because human senses are tuned for thick environments. The cosmos, in these places, is simply too thin for intuition. That thinness can be difficult to picture. So perhaps the best approach is not to force a perfect image, but to accept the mood of it. Imagine the most deserted ocean you can think of. Then remove the water. Remove the wind. Remove the waves. Remove the planet. Keep only the sense of being far from everything. Then stretch that feeling across distances so great that the word far becomes almost meaningless. That begins, emotionally at least, to approach what intercluster space is like. And still, even there, the universe has not vanished. In some regions between clusters, especially along filaments, there may be wandering galaxies, faint dwarf galaxies, or thin streams of gas connecting larger structures. These are not enough to make the region feel crowded. But they remind us that cosmic structure is not made of cleanly separated objects floating in featureless nothing. There are bridges, threads, and gradients. The dark is often stitched with something finer than first appearances suggest. This is one reason astronomers care so much about the dim material between the great clusters. It may hold clues to where some of the universe's ordinary matter ended up. For a long time, a fraction of the normal matter predicted by cosmological models seemed hard to account for. Not missing in the dramatic sense, but difficult to detect directly. Some of it appears to reside in these diffuse intergalactic environments, especially in hot, thin gas spread across large-scale structures. So by studying what seems almost like emptiness, astronomers are actually filling in one of the universe's bookkeeping gaps. That is a lovely kind of irony. The places that look like nothing can help explain where something went. And there is another layer to this. The emptier a region is, the more it can preserve a simpler record of cosmic history. Dense regions are noisy. Clusters are busy, violent, full of interactions, mergers, shock waves, active black holes, and all the turbulence of crowded gravitational life. But sparse regions can be quieter laboratories, less disturbed, more transparent in what they reveal about the broader universe. This is why apparent emptiness is often scientifically precious. Not because there is nothing there, but because there is less clutter. The signal becomes subtler, and sometimes subtler means more revealing. If this quiet unfolding of the universe is helping you drift, you can gently leave a like, Subscribe if you'd like to keep traveling through these calm cosmic questions, and maybe leave a comment sharing what time it is where you're listening from. There is something deeply comforting about imagining many small human nights connected by one enormous universe. There is also a philosophical softness hidden in all this. We often treat emptiness as a lack, as though full places are the meaningful ones and empty places are merely what remains. But the universe does not seem to think that way. Its largest pattern depends on sparse regions as much as dense ones. The great clusters could not stand out without the dark reaches between them. The cosmic web would not have its delicate structure without open volumes around its threads. Emptiness, in this sense, is not failure. It is form. And maybe that is why these intercluster spaces feel so strangely compelling. They are not empty in the disappointing sense. They are empty in the architectural sense. Empty the way a cathedral's interior is empty, making space for height and silence. Empty the way the night sky is empty, making stars visible. Empty the way music needs pauses, so that sound can mean something. The universe makes use of room. A cluster is a gathering. A filament is a connection. The space between them is the room that allows both to exist as part of one larger pattern. That does not make the space full in any ordinary sense. It remains astonishingly sparse. But it changes the emotional meaning of that sparseness. The darkness is not a mistake. It is part of the design. And once you begin to think that way, the question of whether intercluster space is truly empty starts to feel almost too blunt. The better question may be, empty compared with what? Compared with a star? Very empty. Compared with a galaxy? Extremely empty. Compared with a galaxy cluster? Almost unbelievably empty. But compared with nothing at all? Not quite. There is gas, though thin. There is radiation, though faint. There are particles, though elusive. There is dark matter, though less concentrated. There are magnetic fields, perhaps stretched weakly across great distances. There is geometry. There is expansion. There is the cosmic microwave background, still whispering from the beginning. There is structure in low density. There is history written in scarcity. So no, the space between galaxy clusters is not truly empty. It is quieter than almost anywhere the human imagination naturally goes. But it is not blank. It is not erased. It is not a hole torn in reality. It is more like a whispering margin, a thin and subtle realm where the universe is present in its faintest handwriting. And that realization prepares us for the next, even more beautiful step. Because if the great spaces between clusters are not simply blank, then maybe they are not random either. Maybe some of that faint matter is arranged. Maybe those immense separations still belong to a larger pattern. Maybe the darkness between the great cities of the universe is not just darkness, but the open part of a web. That is where we are going next. For now, let the thought settle slowly. The universe's emptiest looking places are not truly nothing. They are places where reality becomes delicate, where matter is thinned to near invisibility, where light becomes whisper soft, where the memory of the early universe still lingers, where even the absence has texture. And perhaps that is one of the gentlest lessons astronomy offers. That what appears empty at first glance may still be full of meaning. Not crowded meaning. Not loud meaning. Just the quiet kind. The kind you only notice when you slow down enough to look. So rest there for a while. Between the clusters. Between the bright gatherings. In the dark reaches where almost nothing lives, and yet the universe still has not let go. Because even there, in the cold and spacious hush between its greatest structures, the cosmos remains quietly, patiently, beautifully alive. Part 6: The Cosmic Web and the Threads Between Giants. If you could step even farther back from the universe, far enough that galaxy clusters themselves began to look small, you would reach one of the most beautiful turning points in all of astronomy. The darkness would stop looking random. That is the moment this whole journey has been quietly moving toward. We began with galaxies, then clusters, then the astonishing distances between them. We let the emptiness stretch out in the mind. We asked whether those enormous spaces were truly empty. And now, with our eyes adjusted to the scale, a larger pattern can finally begin to show itself. Because the universe, on its grandest visible scales, is not a mist of isolated islands scattered without order. It is a web, a vast, delicate structure of threads and intersections, of crowded nodes and open hollows, of matter gathered along long filaments that stretch across unimaginable distances. Galaxy clusters do not simply float alone in the dark. Many of them are connected, linked by the faint architecture of the cosmos itself. And once you see that idea properly, the universe changes shape in the mind forever. It is no longer just a collection of objects. It becomes a pattern of relationships. Imagine standing on a hill at night and looking down at a continent from far above, if such a thing were possible. The cities would glow brightest. Roads would connect them. Some regions would be dense with movement and light, while others would remain dark and open. Now remove the roads, remove the land, remove the oceans, and replace the whole thing with galaxies, gas, and dark matter spread across hundreds of millions of light years. That begins, very gently, to resemble the cosmic web. The galaxy clusters are the great nodes, the bright intersections where matter gathered most strongly. The filaments are the long threads between them, carrying galaxies, gas, and unseen mass across the deep dark. And between those threads lie the wide underdense regions, the great quiet spaces we have already begun to feel. This is the true large-scale shape of the universe. And it did not reveal itself easily. For a long time, human beings could only see the night sky as it appears from inside one galaxy. Even once we learned that other galaxies existed, the larger pattern was still hidden from us. A galaxy on the sky is only a point of light in a certain direction. To understand the true architecture of the cosmos, astronomers had to do something much more difficult. They had to measure not only where galaxies appeared on the sky, but how far away they were. Only then could a three-dimensional map begin to emerge. And when it did, the result was quietly astonishing. Instead of an even spread, galaxies traced lines, curves, walls, clumps, voids. What at first looked random began to reveal a kind of immense lacework. Matter had not filled the universe smoothly. It had collected into a network. There is something deeply satisfying about that discovery, perhaps because it feels like one of those hidden truths that was always there, waiting for the right perspective. From too close, the pattern cannot be seen. Only when you step back does the shape appear. That, in a way, is one of the great lessons of science. Reality often becomes clearer not when we stare harder at one object, but when we widen the frame enough to see how everything connects. So what exactly is a filament? A filament is a long, thread-like structure in the cosmic web, made up of dark matter, gas, galaxy groups, and galaxies themselves. Some stretch across hundreds of millions of light years. Along these filaments, matter is more concentrated than in the surrounding emptier regions, though still far less crowded than inside the cores of major galaxy clusters. If clusters are the great cities of the universe, then filaments are the highways, the trade routes, the long arterial roads across the cosmic night. That comparison is not perfect, of course, but it helps because filaments are not only connections in a geometric sense. They are also pathways of motion. Over vast spans of time, matter flows along them. Gas drifts inward. Small groups of galaxies move through them. Galaxies themselves can fall along these structures toward the deeper gravitational wells at the nodes, where the largest clusters sit. In other words, the web is not a static diagram. It is a living architecture. Very slow living, yes. So slow that no human eye could ever watch it unfold directly. But the movement is there. The universe is always rearranging itself, always deepening some regions, thinning others, feeding clusters from the long slender threads that connect them. It may help to picture dew on a spider web at dawn, though the scale difference is beyond absurd. The droplets gather at intersections. Thin strands connect them. Most of the open air lies between. The structure is delicate, but it holds. The cosmic web has something of that same visual poetry, except its threads are made of matter and gravity, and its droplets are galaxy clusters millions of light years across. And perhaps the most remarkable part of all is this: most of the web is invisible. The galaxies mark it out for us like lanterns on a dark road, but the deeper scaffold beneath is dark matter. That hidden mass is what laid down much of the structure first. Long before the first stars lit up the universe, dark matter had already begun to gather into a loose network under the pull of gravity. Ordinary matter, the gas that would later form stars and galaxies, fell into that invisible architecture. In that sense, the luminous universe grew along a hidden frame. So when we admire the cosmic web, we are admiring the visible expression of something deeper than light. That alone is one of the most humbling facts in cosmology. The largest structures we can map are shaped primarily by something we still do not fully understand. But even without solving dark matter, we can still understand the broad story of how the web came to be. In the early universe, matter was spread with astonishing smoothness, but not perfect smoothness. Tiny fluctuations existed. Small differences in density from one region to another. Nothing dramatic at first. Just slight unevenness, almost like the faintest ripples on a calm surface. But gravity is patient, and patience is one of the great powers of the universe. Over billions of years, the slightly denser regions pulled in more matter. The slightly thinner regions lost matter to their richer neighbors. Slowly, gradually, and relentlessly, the denser parts became filaments and nodes, while the emptier parts opened into the huge underdense spaces we now call voids. The rich got richer. The sparse got sparser. That simple principle, playing out across nearly the whole age of the cosmos, is what gave the universe its large-scale texture. There is something almost tender about that, not because the process itself is gentle, but because the result is so elegant. From tiny early differences came the grandest structure we know, a universe woven from concentration and openness, from threads and hollows. And once you know that, the spaces between galaxy clusters stop feeling like mere gaps. They become the open parts of the design. This is why Part 5 mattered so much. If the darkness between clusters were truly nothing, then the universe would feel more like scattered islands in blank space. But because that darkness belongs to a web, because some of it contains thin filaments, diffuse gas, faint galaxies, and the invisible pull of dark matter, the whole picture becomes richer. The emptiness is not random. It is patterned emptiness. Not all cluster-to-cluster space is the same. Some separations are bridged by filaments, where galaxies are more likely to be found strung along a common path. Other separations open into broader, quieter regions where matter becomes much thinner. This is important, because when we ask about the space between galaxy clusters, we are not always talking about one kind of environment. Sometimes we mean the faint corridors that connect giants. Sometimes we mean the much wider hollows that lie between the corridors themselves. The universe contains both, and the filaments are where the web becomes easiest to feel. Inside a filament, galaxies are not packed tightly the way they are inside a rich cluster, but they are not alone either. They can appear like beads on a thread, spaced across enormous distances yet still part of one larger structure. Gas may drift along the filament. Dark matter provides the underlying gravitational shape. Smaller groups can move inward along these long strands and eventually become part of the larger cluster environment at one end. So in a real sense, filaments help feed the great clusters. They are supply lines of the cosmos. Some of the largest known structures in the universe are related to these web-like arrangements. Astronomers have found colossal walls and filaments of galaxies stretching across hundreds of millions of light years. Names like the Sloan Great Wall or the Hercules Corona Borealis Great Wall have entered the language of cosmology because the mapped universe keeps revealing structure on scales that feel almost unreasonable. Even then, it is important not to imagine one solid object. These are patterns of concentration, not walls like stone. But they still tell the same story. Matter prefers to gather in networks. Our own galactic neighborhood is part of that network too. The Milky Way is not deep inside a rich cluster, but it lies within the broader web, in a quieter region connected to larger structures through the surrounding cosmic landscape. We are not at the center of some special arrangement. We are one small part of the web, on one faint stretch of the universe's immense architecture. There is comfort in that for some people, and unease for others. Comfort, because it means we belong to something larger than ourselves, larger than our planet, larger than our galaxy. Unease, because that belonging comes with scales so immense that it can make human concerns feel like sparks in the wind. But perhaps for sleep, comfort is the better angle to hold. The web suggests that the universe is not random noise. It has form. Not a rigid form, not a designed diagram in the ordinary sense, but a natural large-scale order grown out of gravity and time. There is something soothing about that. Even the darkness has structure. If this slow drift through the architecture of the cosmos is helping you unwind, you can quietly leave a like, subscribe if you want to keep traveling outward into these calm scientific questions, and leave a comment sharing where you're listening from tonight. It is always a gentle thing to imagine many people in many places, all connected by curiosity, while above them stretches the same great web of galaxies. One of the reasons the cosmic web is such a powerful idea is that it changes what we mean by isolation. A galaxy cluster may look like an island from one point of view, but from another, it is a crossroads. A place where several filaments meet. A node where matter has been flowing inward for billions of years. Even a region that seems alone can belong to a wider network. And that wider network can extend far beyond anything we can see with the naked eye. This is especially striking when astronomers simulate the evolution of the universe using computers. Starting from the slight density fluctuations measured in the early cosmos, the simulations allow gravity to work over time. And again, the same broad picture emerges. Threads form, nodes grow, voids open, the web appears. It is one of those rare moments in science where theory, simulation, and observation all lean toward the same deep truth. The large-scale universe really does resemble a web, not because we wished it to, but because the numbers and the maps keep telling the same story. There is also a quiet philosophical lesson hidden in the web's shape. The brightest and most dramatic places in the universe, the clusters, the great gatherings of galaxies, are not self-sufficient monuments standing apart from everything else. They are part of a larger relational structure. Their size, their growth, even their future depend in part on the threads that connect them to the rest of the cosmos. In other words, even on the largest scales, the universe is not only about things. It is about connections. That may be why the cosmic web feels intuitively profound. Human life, too, is shaped by connections more than by isolated existence. Roads between cities, rivers between settlements, signals between minds. The cosmos does not mirror us, of course, but now and then it offers patterns that feel strangely familiar in their logic. Rich nodes, thin threads, open spaces. Presence defined by relationship. Still, it is important not to romanticize the web too much. It is not woven by intention. It is not a design in the human sense. It is what gravity does when given matter, slight unevenness, and billions of years. That is enough. And perhaps that is wondrous enough already. There is no need to add mythology when physics has given us something this elegant. Now, if you were somehow traveling through the web itself, the experience would still be dominated by darkness. Even inside a filament, the galaxies are far apart. The matter is still extremely diffuse by everyday standards. There would be no bright glowing road stretched through space like something from a painting. The web is visible in maps and long observations, not as a luminous highway to the eye. Its beauty is partly conceptual. We know it is there because we have learned how to read the large-scale pattern. That is worth pausing on. Some of the universe's greatest beauty is not immediate. It is revealed through understanding, through learning how to see what the eye alone could never notice. A child sees stars. An astronomer sees galaxies. A cosmologist sees a web. Each vision contains the previous one, but widens it. And when that wider seeing arrives, the darkness becomes more meaningful, not less. The black spaces are no longer just empty backdrop. They are the negative space that gives the web its shape. They are the vast interiors of the cosmic foam, the hollows that make the threads and nodes stand out. That phrase, cosmic foam, is another way some scientists describe the large-scale universe, and it is a helpful one. If you picture bubbles pressed together, their thin boundaries meeting at edges and nodes, you begin to get a feel for how filaments and voids coexist. The galaxies and clusters lie along the denser boundaries. The great emptier regions fill the interiors. The whole structure is less like a solid fabric and more like a delicate cellular pattern stretched across the cosmos. And that brings us naturally to what lies ahead. Because once you understand the web, the next question becomes impossible to avoid. If the clusters are the nodes and the filaments are the threads, then what are the hollows between them really like? How large do they become? How quiet can a region of the universe grow when matter has drained away for billions of years? Those are the great voids. And they are, in many ways, even more haunting than the clusters. But before we go there, let the web settle into your imagination as gently as possible. Not as a chart in a textbook. Not as a complicated scientific model. Just as a shape. A vast cosmic arrangement of glowing intersections connected by faint threads, stretched across darkness so deep that the darkness itself becomes part of the pattern. The universe is not a random spray of galaxies. It is a structure of giants and threads. Clusters at the crossings. Filaments between them. Matter flowing slowly inward. Dark matter shaping what light later reveals. And between all of it, the open quiet that gives the whole design room to breathe. That is the true stage on which galaxies live their long lives. And maybe there is something especially restful in knowing that even the most enormous emptiness is not meaningless. It belongs. It frames. It holds the pattern apart so the pattern can exist at all. So rest with that image for a while. The great clusters, like distant cities of gravity. The long filaments, faint and patient, linking one giant to another. The invisible dark matter beneath it all, carrying the architecture without ever shining. And the vast dark hollows between the threads, waiting for us in the next part of the journey. Because now that we can finally see the web, we are ready to enter its quietest spaces. Part 7, The Largest Voids in the Universe. Now that the web itself is beginning to take shape in the mind, with its glowing intersections and faint threads stretched across the dark, we can finally step into the quietest places of all. Not the clusters, not the filaments, but the hollows between them, the great voids. If galaxy clusters are the universe's grand cities, and filaments are the long roads that connect them, then cosmic voids are the immense open regions where almost no cities were built, and almost no roads pass through. They are not small empty corners. They are not little pockets of leftover darkness. They are some of the largest structures in the known universe, vast underdense chambers where matter grew scarce and the silence became enormous. And perhaps that is the strangest part of all. When people imagine the biggest things in the universe, they usually imagine the brightest things. The biggest galaxy. The biggest black hole. The biggest cluster. Something heavy. Something dramatic. Something that fills space with force or light. But some of the largest structures in existence are defined not by what they contain, but by what they lack. That is the gentle paradox of the cosmic void. It is huge not because it is full, but because it is almost empty. So in this part, let's stay with those vast hollows for a while. Let's understand what a void really is, how large these regions can become, why they formed, what they contain, and why they may be among the most hauntingly beautiful places the universe has ever made. Because once you truly picture a cosmic void, the universe never quite feels crowded again. The word void can sound absolute, almost severe. It sounds like a place where reality has been removed, a gap, a blank, a pure nothing. But in cosmology, the word has a more careful meaning. A void is not usually a place with literally nothing in it. It is a region with far less matter than average, far fewer galaxies, far less gas, far less gravitational activity. It is an underdense region, a place where the universe thinned out as denser regions elsewhere grew richer. This distinction matters, because the void is not outside the universe. It is fully part of it. It still contains spacetime. It still contains faint radiation, trace particles, and a little matter here and there. But compared with the rich nodes of the cosmic web, it is astonishingly sparse. The difference is so great that the void feels almost like a different category of place. And in a sense, it is. A galaxy cluster is an environment where gravity gathered matter strongly. A void is an environment where that gathering largely failed to happen. Or perhaps not failed, exactly. It simply happened elsewhere. Matter drained away over billions of years toward denser regions, leaving behind larger and larger volumes of relative emptiness. This is one of the most important things to understand about voids. They did not begin as giant holes punched into the cosmos. They grew gradually. In the early universe, matter was nearly smooth, but not perfectly smooth. Some regions began slightly denser than average, some slightly less dense. Gravity then amplified those differences. The denser regions pulled matter inward and became filaments, groups, and clusters. The less dense regions lost matter to their richer surroundings and became emptier still. So the voids are not accidents in an otherwise full universe. They are one half of the universe's large-scale evolution. Where there are nodes, there must also be hollows. Where some places gather, other places thin out. The cosmic web and the cosmic voids are born together. And over time, the voids can become enormous. That is the part the human mind needs a little time to adjust to. A void is not just empty space between a few nearby galaxies. Some voids stretch across tens of millions of light years. Some are over 100 million light years across. A few of the most famous and most striking examples reach even larger scales still, becoming so large that they begin to feel less like regions and more like absences written into the structure of the cosmos. One of the best-known examples is the Boötes void, sometimes called the Great Nothing. Even the nickname feels a little dramatic, but in this case the scale almost justifies it. The Boötes void is roughly 250 to 330 million light-years across, depending on how its boundaries are defined. That is such an immense volume of space that even saying it softly does not make it easier to hold. It is not merely big. It is too big for direct intuition. It is a region where, compared with what astronomers would normally expect, galaxies are astonishingly rare. To appreciate just how strange that is, it helps to remember what is being compared. In a region of that size, if the universe were more evenly populated, you would expect many more galaxies. Thousands, perhaps, depending on the precise volume and density assumptions. Instead, astronomers found a remarkable deficit. A giant hollow in the map. A place where the universe seemed to go unusually quiet. That discovery had a very particular emotional effect on astronomy. It was not just a data point. It was unsettling. Because it told us the universe was not merely clumpy. It was hollow on scales large enough to feel almost unreasonable. And once one void is found, others follow. Not all is famous, not all is extreme in public imagination, but part of the same overall reality. The universe contains many voids. Some are smaller and more common. Some are larger and more dramatic. Many are not perfect spheres, because the web itself is irregular and organic in shape. Voids can be stretched, merged, flattened, or gently distorted by the surrounding distribution of matter. But whatever shape they take, their essence remains the same. They are the large, quiet chambers of the cosmic web. It may help to think of the universe not as a solid fabric, but as something closer to foam. In foam, the important features are not just the thin walls and intersections, but also the bubbles themselves, the interior open regions. The walls define the bubbles, and the bubbles define the walls. In the same way, the great filaments and clusters of the universe surround vast underdense spaces. The web gives shape to the voids, and the voids give shape to the web. This is why the voids are not secondary. They are not just what is left over after the important structures form. They are part of the main architecture. In fact, by volume, the emptier regions dominate. Most of the universe, in terms of sheer space, is not taken up by galaxies or clusters. It is taken up by the wide, quiet regions between them. The bright structures get our attention because they shine, but the voids get the room. That changes the emotional balance of the cosmos quite a bit. It means the universe is not mostly made of the things we notice first. It is mostly made of spaciousness. And perhaps that is why the voids feel so restful and so eerie at the same time. They take the idea of cosmic emptiness and expand it until it becomes the rule rather than the exception. Now, what would it actually be like inside one of these vast voids? The first answer is distance. Distance in every direction. The galaxies that do exist inside a void are usually few, widely spaced, and often smaller or more isolated than galaxies in denser environments. If you were somehow placed near the center of a large void, you would not be surrounded by the busy architecture of a cluster. You would not see a nearby wall of galaxies. You would be in a place where the nearest significant structures could lie immensely far away, spread thinly around the edges like faint coastlines around a dark ocean. That coastline image is one of the most useful ways to picture a void. The galaxies and filaments are like the shores and island chains of a cosmic sea. The void is the wide water between them, except darker, emptier, and far more still. If you were deep within it, the larger structures of the web would be remote, dim, and almost ceremonial in their distance. Some astronomers have noted that if our own galaxy had existed near the center of a giant void like Boötes, the history of human astronomy would have been dramatically different. The night sky might not have shown other galaxies clearly enough for us to recognize them until very recently in scientific history, if at all. Imagine that for a moment. Imagine looking up from Earth and seeing only the stars of your own Milky Way, with no clear evidence that other great galaxies existed beyond it. The sense of cosmic structure would arrive late, reluctantly, perhaps painfully slowly. That thought makes the void feel even larger in a human sense. It is not just a sparse region on a map. It is a place where the visible universe could feel much smaller to any civilization living inside it. There is another fascinating layer to voids as well. Because they are relatively isolated and less disturbed by the violent interactions common in clusters, the galaxies that do exist within them can become valuable laboratories for astronomers. In crowded environments, galaxies are constantly tugged, stripped, heated, merged, and reshaped by their surroundings. But in voids, a galaxy may live a more solitary life. It may evolve with fewer major interruptions, preserving clues about what galactic life looks like in a quieter setting. So even the emptiest regions can still teach us something rich. That, in a way, is one of the recurring comforts of cosmology. The quiet places are not meaningless. They are revealing precisely because they are quiet. If this calm descent into the largest hollows of the cosmos is helping you settle, You can quietly leave a like, subscribe if you want to keep drifting through these slow scientific journeys, and maybe leave a comment sharing where you're listening from tonight. It is always a gentle thing to imagine many small human homes connected by one enormous, mostly silent universe. One of the strangest properties of voids is how they evolve over time. Because they contain less matter, gravity inside them is weaker than in denser regions. That means they do not resist cosmic expansion in the same way clusters do. On the largest scales, the emptier regions can expand more effectively, becoming emptier still relative to their surroundings. In a very broad sense, the voids grow as matter continues to prefer the richer nodes and threads of the web. This gives voids a kind of slow dynamism. They are not frozen gaps. They are expanding hollows. Their boundaries shift. Smaller voids can merge into larger ones. Their interiors can become more underdense over time. They are active participants in the universe's large-scale evolution, not passive holes in the map. And there is something almost poetic about that. The emptiest places are not static. They widen. The quiet deepens. The room increases. It makes the universe feel less like a finished structure and more like a long unfolding one, where even absence has a history. There are also larger, more controversial underdense regions sometimes discussed by cosmologists, such as the proposed KBC void, an enormous local-scale underdensity suggested by some observational studies. Whether its exact size and significance are still debated or refined, the very existence of such discussions reveals something important. Once astronomers began mapping the universe carefully, underdense regions stopped being curiosities and became central to how we understand our cosmic address. We do not only ask where the clusters are. We also ask whether our own region is richer or poorer than average, busier or quieter than the broader universe. That is an extraordinary shift in perspective. It means even emptiness can be local. Even the silence has geography. And then there are supervoids, an even more dramatic term for exceptionally large underdense regions. Again, the boundaries and definitions can be tricky, because the universe is not partitioned into neat geometric compartments. But the idea remains powerful. Some regions appear underdense on scales so broad that they begin to intersect with our biggest cosmological questions. They may affect how light passes through them, how we interpret large-scale structure, and how we understand the expansion of the universe on certain scales. One famous example tied to these discussions is the Eridanus supervoid, sometimes associated with the CMB cold spot, a region in the cosmic microwave background that appears unusually cold. The details are still debated, and the full explanation is not settled, but the very fact that a vast underdense region could influence how we observe the afterglow of the early universe tells you how significant voids really are. These are not merely empty sidelines. They are part of the stage on which cosmology itself is performed. Still, even without following every debated detail, the broader point is beautifully clear. The largest voids are among the largest coherent features we know. They are places where the universe's unevenness becomes breathtakingly obvious. Places where the cosmic web opens so wide that the darkness begins to feel architectural. And perhaps this is where the emotional meaning of the void becomes deepest. We often think of emptiness as a lack of form, but the void shows the opposite. Emptiness can have shape. It can have boundaries, history, texture, and role. It can be part of a grand design without ever being crowded. The void is not shapeless nothing. It is shaped spaciousness. That phrase may sound a little unusual, but it fits. A cosmic void is spaciousness made structural. It also teaches us something subtle about perspective. On human scales, empty space feels like background. A room feels empty when no one is in it. A road feels empty when no cars pass. A field feels empty when nothing obvious occupies it. But on cosmic scales, emptiness is not mere background. It is one of the main outcomes of the universe's evolution. It is where the web did not thicken. where gravity did not win as strongly, where time turned slight scarcity into profound openness. So the void is not just where things are missing, it is where one of the universe's deepest processes becomes visible. That may be why so many people find these ideas both soothing and unsettling. On one hand, the void strips away clutter. It is stillness on a scale beyond anything in daily life. On the other hand, it also removes the comforting illusion that the universe is densely populated with luminous things. Most of reality, by volume, is quiet. Most of the great stage is dark. But perhaps dark does not need to mean lonely. After all, the void is still part of the same universe that made stars, planets, oceans, and living minds. The same laws hold there. The same ancient background radiation fills it. The same space-time stretches through it. The same cosmic history reached it. It is not outside the story. It is simply one of the story's calmest chapters. And maybe that is the most sleep-friendly way to hold it. Not as terrifying nothingness, but as cosmic stillness. A place where the universe relaxed its grip. A place where matter thinned, motion softened, and the architecture opened into wide dark chambers. It is easy to imagine the universe as dramatic all the time, full of explosions and collisions and blazing stars. And certainly, those things are real. But the void reminds us that the universe also knows how to be quiet. Vastly quiet. Patiently quiet. Quiet on scales so large that even whole galaxy clusters begin to feel like rare interruptions. There is something deeply calming in that. So let the image settle in slowly now. Picture the cosmic web stretched across the darkness. Bright intersections where clusters gather. Long threads of filaments connecting them. And between those threads, great hollows opening out in all directions, larger than any city of galaxies, larger than any one cluster, sometimes larger than our minds naturally know how to picture. The largest voids are like the deep water between distant island chains. Like vast valleys where almost no lights are lit. Like silent rooms inside the universe's grand architecture. Chambers formed not by walls of stone, but by the slow withdrawal of matter toward richer places elsewhere. And inside those chambers, the darkness is not absolute, but it is profound. A few galaxies may drift there. Thin gas may linger. Ancient radiation still passes through. But compared with the brightness of clusters and the gentle traffic of filaments, the void remains what it has always been, one of the quietest and largest expressions of cosmic structure. In the next part of the journey, we'll take that quiet one step further and ask what it would actually feel like to cross such a place. Not just what astronomers measure, but what the experience would be like if a traveler could somehow move through the vast space between galaxy clusters and voids. What would be seen? What would not be seen? How would time itself feel in a region where almost nothing changes? For now, though, stay here. In the great hollows. In the largest quiet chambers the universe has ever made. And let the thought do what it does best. Let it soften the mind. Let it widen the room around your thoughts. Let it remind you that the cosmos is not only a place of brilliant objects, but of enormous pauses between them. Because sometimes the biggest thing in the universe is not a thing at all. Sometimes it is the silence surrounding everything else. Part 8. What it would feel like to cross the space between galaxy clusters. Now that we have stood at the edge of the great voids, and let their size settle into the mind, there is another question waiting quietly in the dark. What would it actually feel like to travel there? Not just to know the numbers. Not just to admire a map. But to cross it. To leave behind the last crowded region of the cosmic web, the last great gathering of galaxies, and move outward into the immense hush between galaxy clusters. To enter a place where the nearest landmarks are so far away that distance stops feeling like geography and starts feeling like time itself. It is a beautiful question because it takes something abstract and gives it atmosphere. And once atmosphere enters the imagination, even the largest scientific idea becomes easier to feel. So for this part, let's slow everything down and imagine the journey itself. Not in a loud or cinematic way. Not as a race through space with engines blazing and alarms ringing. That would be the wrong mood entirely. The space between galaxy clusters is not dramatic in that sense. It does not shout. It does not flash. It does not rush to impress you. It does something stranger. It removes almost everything. And in that removal, it changes the meaning of travel. Imagine that you begin inside a galaxy cluster. Behind you are thousands of galaxies, though from any one position inside the cluster they would still not look crowded in the ordinary sense. The cluster is already vast beyond comprehension, but there is still structure there. A sense of belonging to a gravitational city. A sense that matter gathered successfully in this region. Galaxies drift in the common well of dark matter. Hot gas glows faintly in X-rays, even if your human eyes could never see it directly. The cluster has weight, shape, and history. Then you begin to leave it. At first, the change might not seem dramatic. The galaxies thin gradually. The environment becomes less crowded on cosmic terms. The invisible sea of hot intracluster gas grows less dominant. The common pull of the cluster begins to loosen. If you were traveling outward for long enough, the grand city would begin to feel less like a city and more like a memory behind you. And ahead? Ahead there would be dark. Not the darkness of a room with the lights turned off. Not the darkness of the countryside under a moonless sky. Those darknesses still belong to places rich with nearby things. This would be a different order of dark. A darkness with no nearby weather, no nearby ground, no nearby source of warmth, no horizon to define space for you. A darkness so extended that it would not feel like an absence of light in one location. It would feel like the natural condition of reality itself. That may be the first real emotional truth of crossing intercluster space. The darkness would stop feeling temporary. It would become the setting. And yet, even here, it would not be absolute. There would still be distant galaxies. There would still be the ancient cosmic microwave background bathing all of space. There would still be stray photons crossing the universe. But almost all of that would remain conceptually present rather than visually rich. To the eye, if human eyes could survive or matter in such a setting, the overwhelming impression would be distance and scarcity. You might still see remote galaxies as faint islands of light far away, but they would not guide you the way stars guide sailors. They would be too far, too sparse, too detached from your immediate surroundings. They would not make space feel inhabited. That is what would be most unsettling and most calming at the same time. The journey would have no scenery in the ordinary sense. On Earth, travel is marked by change. A road curves. Trees pass. Buildings rise and fall away. Clouds shift. Mountains appear on the horizon. Even on the open sea, the light changes, the waves move, the weather evolves. There is always some texture of motion. But in the space between galaxy clusters, especially in the emptier regions, you could travel for distances so large that the scene would change only with unbearable slowness. It would not feel like motion through a landscape. It would feel like motion through absence. That may be one of the hardest things for the mind to accept. We usually think of movement as being revealed by passing objects. But what if there are almost no nearby objects to pass? What if your surroundings barely change, not for hours or days, but for spans so immense that human history would be too short even to describe them? Then movement becomes philosophical rather than sensory. You know you are traveling, but the universe does not provide enough local detail to make that travel feel immediate. This is why the great spaces between clusters feel so haunting in imagination. They would empty out not only the view, but the experience of progress itself. A traveler crossing one of these regions would have to live with long periods where almost nothing seems to happen. And maybe that is what makes the image so strangely suited to sleep. It is a place beyond interruption, beyond noise, beyond clutter, beyond the ordinary flood of stimuli. A place where the universe itself has settled into sparse, patient silence. Still, there would be subtle things. If you were able to observe carefully enough, the arrangement of very distant galaxies would slowly shift over unimaginable stretches of travel. Not quickly. Not in a way the human nervous system was designed to enjoy. But over time, the cosmic background of structure would adjust. One great cluster behind you would fade into deeper remoteness. Another ahead might begin, very gradually, to separate itself from the general darkness as a more definite destination. And even then, it would remain profoundly far away. This is where the emotional weight of light years becomes hardest to ignore. If the next major structure is tens of millions of light years away, then even light takes tens of millions of years to make the journey. That means any traveler moving slower than light, which would be anything physically realistic as far as we know, would experience the crossing as something beyond any civilization-scale project. It would not be a voyage in the age of humans. It would be a voyage on the scale of species, continents, and eras of life. So perhaps the better way to imagine it is not as a practical mission, but as an exercise in feeling the scale of the universe from the inside. To travel between galaxy clusters would be to enter a realm where destination loses much of its usual meaning. Not because the destination is unclear, but because the path is so enormous that the path itself becomes the main reality. It is almost like the universe asking a question: what happens to the mind when it is placed in a journey made mostly of nothing? Perhaps the first answer is loneliness. That would be the easy answer, at least. And certainly some kind of cosmic isolation would define the experience. There would be no nearby worlds. No neighboring stars close enough to warm space around you. No familiar sky full of local glitter. Even the nearest galaxy might be so far that it feels more symbolic than present. But loneliness is not the only possible feeling. There is also purity. The stripping away of distraction. The sense of being in contact with the universe at its most spacious and least crowded. Of seeing reality not where it gathers into brilliance, but where it opens into immense quiet intervals. On Earth, silence is almost always interrupted. On human scales, emptiness is usually temporary. But between galaxy clusters, the silence would not be something imposed for a moment. It would be the native mood of the place. There is a certain peace in that, if you allow yourself to meet it gently. Not a warm peace. Not a cozy one. A colder peace. A cleaner peace. The peace of deep winter night, multiplied beyond any familiar boundary. If you could somehow stand in that region and look in all directions, perhaps the most striking thing would be how little the universe seems to demand from you. No nearby gravity well to dominate your view. No immediate event. No rush. No weather. No traffic of matter. Only the knowledge that you are suspended within a vast architecture whose nearest bright intersections lie far beyond instinct. And yet the space would not be dead. That is important. Even while almost nothing seems to happen, reality would still be there in its faintest forms. Thin traces of gas. A few particles drifting through. Ancient microwave background radiation filling every direction. Weak magnetic fields perhaps threading enormous scales. The slow expansion of spacetime itself subtly participating in the region's larger history. So the journey would not be through non-existence. It would be through delicate existence. Through a place where the universe writes very lightly. And maybe that is a more accurate phrase than emptiness. Not nothingness, but light handwriting. A realm where matter, radiation, and structure have been thinned until they are almost whispers. If this slow passage through the quiet reaches of the cosmos is helping you unwind, you can gently leave a like, subscribe if you'd like to stay with these kinds of calm explorations, and maybe leave a comment sharing where you're listening from tonight. There is something quietly beautiful about imagining small human rooms scattered across Earth while the mind wanders through distances large enough to silence almost everything. Another strange aspect of this imagined crossing is the way time would begin to feel. Normally, we think of time through change. Morning becomes afternoon. Afternoon becomes evening. A plant grows. A shadow moves. A face ages. Even in space, a planet rotates, a moon orbits, a star rises and sets from some local horizon. But in the broad emptiness between galaxy clusters, very little nearby change would exist to mark time. The background of the universe would be so sparse that time might begin to feel almost featureless. This is not because time would stop. It would not. But because so few local events would occur within any short interval, the experience of time would become more abstract. You would rely less on the environment to tell you time is passing, because the environment itself would seem almost indifferent to short durations. A day would mean almost nothing there. A century, almost nothing. Even 10,000 years would barely disturb the visual arrangement of the nearest great structures. That thought has a way of cooling the mind. It reminds us how much human urgency depends on living in fast-changing environments. On a planet full of weather, biology, and activity, everything feels immediate. But in the great stretches between clusters, immediacy evaporates. The universe becomes patient on a scale that makes impatience feel almost local, almost accidental. And maybe there is comfort in that. The thought that not every realm of existence is busy. Not every part of reality is packed with demands. Some of it is just room. Some of it is long, deep intervals between the brighter chapters. Now imagine crossing not just a normal intercluster region, but the deeper interior of a vast void. Then the experience becomes more extreme still. The filaments would be farther away. The clusters more remote. The few galaxies that do exist in the void might be isolated and dim. The sense of being far from major structure would intensify. It would feel less like moving between great cities and more like crossing an ocean so broad that even the memory of coastlines begins to weaken. This may be the closest emotional comparison available to us. Deep ocean travel before modern navigation, but stripped even further down. No wind, no waves, no sound of water. No stars arranged in helpful patterns nearby. Only a dark expanse where the nearest islands of light lie at absurd distances. And unlike a sea voyage, the crossing would offer almost no medium to touch. No water beneath you. No ship creaking. No air against your skin. The silence would not just surround the traveler. It would pass through the very concept of environment. That is why the journey through void space feels almost spiritual in imagination. Not because it is mystical, but because it removes so many ordinary anchors that the mind is left face to face with scale itself. And scale, when it becomes too large to picture directly, has a curious effect. It can unsettle the mind, yes, but it can also quiet it. Because eventually the effort to fully comprehend it gives way to something else. A kind of surrender. A willingness to simply float in the idea without mastering it. That is often the most restful way to meet the cosmos. Not by forcing understanding until it snaps into sharp detail, but by letting the scale remain large, letting the dark remain wide, letting the imagination drift rather than conquer. There is also something important to say about sound. There would be none, at least not in the ordinary way. Space does not carry sound the way air does, because sound is a vibration moving through a medium. In the near vacuum between galaxy clusters, there is far too little material for sound as we know it to travel meaningfully. So the journey would be silent in a more absolute sense than any earthly silence. Not the silence of a forest at night. Not the silence of snowfall. Those silences are full of tiny hidden sounds. This would be closer to the absence of sound itself. And still, the human mind would probably create its own inner noise. Memory, thought, expectation. Which may be why imagining such a place can be useful in a sleep-like way. It invites us to notice how much noise we carry within, even when the outer world falls quiet. The universe between galaxy clusters would not entertain you. It would not distract you. It would simply remain what it is, vast, sparse, patient, and mostly unchanged. In that sense, it would be one of the most honest places imaginable. A place where reality makes no attempt to flatter the human timescale. Perhaps one of the most moving things about this imagined crossing is the way it reveals what clusters really are. From inside one, a cluster is an environment, a home region for galaxies, a place with depth and history. But once you leave it behind and enter the intercluster dark, the cluster transforms in meaning. It becomes an oasis, a rare concentration of matter in a universe otherwise dominated by enormous intervals. And that shifts the emotional balance of cosmology again. It tells us that the bright places are not the background. They are the exceptions. The true background is spaciousness. The true stage is the dark between the great structures. A traveler crossing that stage would come to feel this very deeply. Not as a theory, but as the lived texture of the journey. Every hour, every year, every 1,000 years of nearly unchanged surroundings would reinforce the same quiet lesson. The universe gives most of its volume to separation, and yet that separation is not meaningless. It defines the pattern. It frames the clusters. It makes the filaments visible. It allows the web to breathe. Without the open spaces, the great structures would lose their shape. Without the silence, the lights would lose some of their meaning. That may be one of the most soothing truths in this whole subject. The empty-looking parts are not wasted space. They are the intervals that allow structure itself to exist. So what would it feel like to cross the space between galaxy clusters? It would feel slow beyond all ordinary patience. It would feel dark in a way that ceases to be dramatic and becomes elemental. It would feel silent beyond anything we call silence on Earth. It would feel almost changeless, because the nearest structures are so far away and the environment so sparse. It would feel isolating, yes, but also strangely pure, as though the universe had reduced itself to its quietest form. And most of all, it would feel like traveling through the part of reality that usually remains hidden behind the brighter things. The long intervals. The great pauses. The enormous room between the nodes. That is the atmosphere of intercluster space. And in the next part of this journey, we'll move from feeling to meaning. We've now imagined the crossing itself, the silence and slowness of those immense dark reaches. But what does all this scale actually change in the way we understand the universe? Why does the space between clusters matter so much, not only as a scientific fact, but as a clue to the deeper shape of reality? For now, though, just rest with the crossing. Imagine the last galaxy-rich region fading behind you. Imagine the filaments growing distant. Imagine the nearest great cluster ahead remaining only a faint promise in the dark. And between them, all that room, all that time, all that almost empty quiet through which even light must travel for ages. If there is a place in the universe where thought can thin out and drift, it may be there. In the long, silent crossing between giants. Part 9. Why these distances change the way we see reality. After imagining the crossing itself, after drifting in thought through the long silent stretches between galaxy clusters, there is one final question before this journey begins to close. What does all of that distance actually do to the way we understand reality? Because some scientific facts remain at the level of information. They are interesting, perhaps even impressive, but they do not really change the emotional shape of the universe. You learn them, you nod, and then you set them aside. But some facts do something deeper. They rearrange the background of thought. They alter scale itself. They make familiar things feel newly strange. And the true size of the space between galaxy clusters is one of those facts. It changes the universe from a place filled with objects into a place defined by intervals. It changes matter from being the obvious main character into something more like a delicate pattern spread over immense darkness. It changes light from feeling normal to feeling rare. And perhaps most quietly of all, it changes us. Not physically, of course. The stars do not move because we understand them better. The clusters do not care what we think. But the inner map changes. The mind shifts. And once it does, the night sky never quite looks the same again. So let's stay with that shift for a while. Not with the measurements now, not with the catalog names, not with the technical language, but with the meaning of it. What it means to live in a universe where even the greatest gatherings of galaxies are separated by distances so large that the emptiness between them becomes one of the dominant features of existence. The first thing it changes is our sense of what the universe is mostly made of. Most of us grow up, quite naturally, thinking the universe is made of things: stars, planets, moons, nebulae, galaxies, objects, visible structures, the bright, the massive, the dramatic. And that makes sense, because those are the parts we can see most easily, the parts that photographs celebrate, the parts that enter memory first. But when you step far enough back, the balance changes. You begin to realize that the universe is not mostly objects. It is mostly room, mostly separation, mostly vast dark intervals between the places where matter managed to gather. This is one of the deepest emotional reversals in astronomy. The visible things are not the full story, and not even the dominant one in terms of volume. The stars are precious, yes. Galaxies are magnificent, yes. Clusters are extraordinary. But they are the threads and intersections, not the whole cloth. The great open spaces between them are not a side detail. They are the main stage. And that is hard for the human mind, because human life is built in dense environments. We live among surfaces, voices, walls, roads, bodies, weather, events. Even our silences are usually full of hidden presence. But the large-scale universe is not built that way. It gives most of its space to openness. That realization does not merely add information. It changes proportion. It tells us that reality, on its grandest scales, is less like a crowded city and more like a delicate pattern stretched across a vast quiet sea. And once that idea settles in, another change follows. You begin to understand that emptiness is not the opposite of structure. It is part of structure. This may be one of the most beautiful lessons hidden inside the space between galaxy clusters. At first, emptiness sounds like the lack of something, the absence of matter, the failure of formation, the leftover dark after the important things have taken their places. But the cosmic web teaches something subtler. The empty regions are not meaningless leftovers. They help define the pattern itself. A filament only looks like a filament because there is open darkness around it. A galaxy cluster only feels like a node because there is so much room between it and the next one. A web needs empty spaces to be a web at all. In that sense, emptiness is not outside the architecture of the universe. It is one of the conditions that makes architecture visible. That is a surprisingly comforting thought. It suggests that absence is not always failure. Silence is not always lack. A pause can shape a melody. A blank margin can shape a page. Darkness can shape light. And on the grandest scales, the spaces between the clusters shape the entire visible universe. There is also a deeper philosophical shift here, one that arrives quietly. The more we learn about the universe, the less reality seems centered on the kinds of scales that feel natural to us. This has happened many times in the history of science. Earth is not the center of the solar system. The sun is not the center of the galaxy. The Milky Way is not the whole universe. Our local group is not a special cosmic neighborhood set apart from everything else. Again and again, our intuitive center has moved outward and dissolved into a larger frame. The distances between galaxy clusters continue that same humbling tradition. They remind us that even galaxies, those immense cities of stars that once felt like ultimate objects, are themselves tiny participants in a much larger geography. Entire clusters, which already seem impossibly grand, become points in a broader web. And the spaces between those points are so wide that our ordinary categories begin to crack under the pressure. This does not make human life less meaningful, but it does make it differently placed. It invites a softer kind of humility. Not the humiliating kind, not the crushing kind, but the quiet realization that reality is under no obligation to be built around the scales we find comfortable. That can be unsettling at first, but it can also be deeply calming. Because once you stop expecting the universe to resemble human life in proportion, it becomes easier to admire it for what it is: vast, layered, mostly silent, organized in ways that make cities, countries, and even planets feel like local phenomena inside a much older and wider arrangement. And then there is time. The scale of the space between clusters changes the meaning of time almost as much as it changes the meaning of distance. On Earth, distance and time are often linked in manageable ways. A walk takes minutes. A flight takes hours. A voyage takes days or weeks. Even long projects have a sense of rhythm the body can understand. But on the scale of intercluster space, time begins to lose its ordinary emotional shape. A beam of light, the fastest thing in the universe, can spend tens of millions of years crossing the gap between major structures. Entire species can appear, flourish, and vanish while that crossing is still incomplete. When a distance demands that kind of time, it no longer feels like a route. It feels like an era. And that changes how reality itself feels. It reminds us that some parts of the universe are not merely large in a spatial sense. They are large in a historical sense. Their scale is so great that time must be recruited just to describe the crossing. That makes the universe feel less like a set of places and more like a set of durations. The open regions between clusters are not just where there is little matter. They are where time becomes long enough to overwhelm narrative instinct. There is no simple human storyline that fits comfortably in a journey millions of years long. The mind has to yield. It has to stop demanding immediacy. It has to let scale remain scale. And perhaps that is one reason this subject is so restful when approached slowly. It gently weakens the nervous system's addiction to urgency. It places ordinary concerns inside a frame so large that they no longer need to be solved right away in order for existence to remain beautiful. There is another important shift that comes from understanding these immense separations. It changes what counts as full. A galaxy cluster feels full because galaxies are gathered there in unusual numbers. A filament feels more occupied than a void because it contains a thread of matter. But full and empty are relative words. Cosmology teaches us to think in densities, gradients, and contrasts, not simple absolutes. A region may feel nearly empty to us and still contain gas, radiation, particles, dark matter, and large-scale influence. A region may feel crowded by cosmic standards and still be, in any everyday sense, almost unfathomably sparse. This matters because it moves the mind away from rigid categories and toward texture. Reality becomes less binary. Not something or nothing, but more and less. Not presence or absence, but concentration and thinning. That may sound small at first, but it changes a lot. It makes the universe feel more organic, more like a landscape of gradients than a machine assembled from separate pieces. The spaces between galaxy clusters are not clean blank gaps. They are low-density regions in a larger pattern, places where matter is stretched thin rather than erased. And once you begin thinking that way, the whole cosmos feels subtler. The brightest structures stop being isolated trophies and become high points in a terrain. The emptiest regions stop being failures of content and become low valleys in the same terrain. Everything belongs to the same broad field. This is also where the large-scale universe begins to feel strangely intimate in a conceptual way. Not intimate because it is small or close, but because it follows principles we can slowly understand. Gravity amplifies tiny differences. Matter gathers in some regions. Other regions empty out. Filaments connect nodes. Voids widen. Clusters feed on the flows of surrounding matter. The web emerges. The dark intervals dominate the volume. The pattern is vast, but it is not arbitrary. And that is a comforting thing to remember in a universe this large. That beyond the scale and darkness there is still intelligibility. Not total understanding, perhaps. Not all mysteries solved, but enough order that the mind can rest inside it. If this quiet unfolding of the universe is helping you relax tonight, you can gently leave a like, subscribe if you'd like more slow journeys like this, and maybe leave a comment sharing where you're listening from. There is something lovely about that contrast, small human lives in different rooms across one small planet, all reflecting for a moment on a cosmos so large that entire galaxy clusters feel like scattered lights. Another way these distances change reality is by changing the meaning of importance. In daily life, importance is often tied to size, nearness, urgency, or usefulness. But the universe does not really operate that way. Some of its most important features are almost invisible. Dark matter shapes the web without shining. Dark energy influences cosmic expansion without offering a visible form. The spaces between clusters, apparently empty at first glance, turn out to be central to the very structure we are trying to understand. So the lesson becomes harder to ignore. What matters most is not always what glows brightest. That is a beautiful correction. It means the visible universe is only one layer of reality, perhaps the most emotionally immediate layer, but not always the most structurally decisive one. The biggest story may be happening in the arrangement, in the relationships, in the balance between gathering and separation, not merely in the luminous objects themselves. In other words, the universe is not only made of things, it is made of spacing. Spacing is what allows clusters to stand apart as distinct structures. Spacing is what lets filaments stretch across the dark. Spacing is what gives the web its shape. Spacing is what allows emptiness to become a physical and philosophical fact rather than just an absence. That may be why learning about the space between galaxy clusters changes the mind so deeply. It reveals spacing as substance, not in the chemical sense, but in the architectural sense. The intervals matter. The pauses matter. The dark is part of the design. And then, perhaps most personal of all, there is the way this knowledge changes the night sky itself. Because once you know what lies beyond what you can see, the sky becomes layered. The stars are no longer just stars. They are local lights inside one galaxy. That galaxy is no longer just a grand isolated object. It is part of a group, part of a broader region, part of a web. Other galaxies are not merely distant smudges. They are members of larger structures, themselves separated by gulfs so immense that even light takes ages to cross them. The darkness between visible objects stops feeling empty in the casual sense. It becomes charged with meaning, not because it is crowded with hidden wonders in every direction, but because it holds the architecture together. The black between the stars is not the same as the black between galaxies, and that is not the same as the black between clusters. Different scales of darkness contain different kinds of story. Some are filled with nearby stellar neighborhoods, some with galactic outskirts, some with intergalactic gas and faint structures, some with the deepest quiet of the cosmic web. The sky becomes less like a flat ceiling and more like a layered depth with many kinds of silence inside it. That is a profound gift of cosmology. It teaches depth where the eye first sees flatness. It teaches structure where intuition first sees scattered points. It teaches that even the dark has geography. And perhaps that is what this whole journey has been leading toward. Not just the answer to how large the spaces between galaxy clusters really are, but a change in the way reality itself feels once that answer is allowed to breathe. Because the answer is not just very large. It is something richer than that. It is that the universe is built on scales where separation becomes one of the main features of existence. It is that matter lives in patterns of concentration surrounded by vast openness. It is that the bright places we notice first are not the whole story, and perhaps not even the largest part of it. It is that silence, distance, and spacing are not empty ideas in cosmology. They are structural facts. And all of that has implications beyond astronomy. It suggests a softer relationship to scale, a more patient relationship to time, a more nuanced relationship to emptiness, a more generous understanding of what counts as part of a pattern. Maybe that is why people often feel unexpectedly emotional when they truly think about the universe. Not because science itself is sentimental, but because reality, when seen clearly enough, can be quietly overwhelming. Not in a violent way. More like standing at the edge of a calm ocean at night and realizing that the darkness is not blank. It is depth. The universe gives that feeling again and again. And the space between galaxy clusters may be one of its purest expressions. There is another gentle lesson here too. Human life often feels packed, crowded with demands, notifications, deadlines, conversations, unfinished thoughts. We live inside density. So perhaps there is a special relief in contemplating a universe where the dominant condition is not pressure, but room. Enormous room. Room enough for whole galaxy clusters to be separated by millions upon millions of light years. Room enough for silence to become architecture. Not because we want to escape life, but because the mind sometimes needs a wider frame in order to soften its grip on smaller worries. The cosmos offers that frame, and it does so without asking anything from us except attention. Just attention, and a willingness to let scale remain large. So when we say that the true scale of the space between galaxy clusters changes the way we see reality, this is what we mean. It changes the material balance of the universe in our imagination. It changes the emotional status of emptiness. It changes the role of light. It changes the meaning of travel and time. It changes the sky from a scattering of lights into a layered architecture of nodes, threads, and immense intervals. It changes us from residents of a crowded cosmos into observers within a delicate one. A cosmos where the silence is the rule and the lights are the exceptions. A cosmos where the great gatherings of matter are real and beautiful, but where the vast open distances between them are just as important. And perhaps, in the calmest sense, just as beautiful. So let that settle now. Let the idea rest the way large ideas often do, not as something solved, but as something spacious enough to drift inside. The universe is not only what shines. It is also what separates the shining things. It is not only the galaxies and clusters. It is also the room between them. It is not only the visible matter. It is also the invisible structure, the long timescales, the faint ingredients, the widening voids, and the great open dark that makes the whole pattern possible. And once you know that, reality feels a little less crowded, a little more profound, and a little more quiet. In the final part of this journey, we'll bring everything together and end with the deepest, calmest thought of all, what emptiness on this scale means. Not just scientifically, but emotionally. What it says about the universe that so much of it is made not of brilliant objects, but of room, silence, and delicate separation. Part 10. The meaning of emptiness on a cosmic scale. And so, after all of that distance, after the galaxies, the clusters, the filaments, the voids, and the long silent crossings between them, we arrive at the calmest question of all. What does this emptiness mean? Not just what is it made of, not just how large it is, not just how astronomers measure it or map it or give it names, but what does it mean that the universe, on its largest scales, is built this way? What does it mean that even the great cities of galaxies are separated by such profound distances? What does it mean that the grand architecture of reality is not a dense and crowded tapestry, but a delicate web stretched across an ocean of almost nothing? This is where science becomes quietly philosophical, not because it stops being science, but because some facts are simply too large to remain only technical. They enter the imagination. They change the mood of reality. They make us feel the universe differently. And perhaps the deepest feeling hidden in all of this is not fear. It is perspective. Because when you first hear about the space between galaxy clusters, it can sound harsh. It can sound cold. It can sound like the universe is mostly empty, mostly dark, mostly silence. And in a literal sense, that is true. But once you stay with the idea long enough, once you let it breathe a little, it begins to feel less harsh and more profound. The emptiness is not a mistake. It is not a failure of creation. It is not unused space in a universe that ran out of things to place there. It is part of the form, part of the structure, part of the meaning of the whole. That may be the first and gentlest truth to carry from this journey. The large empty spaces between galaxy clusters are not signs that the universe is unfinished. They are signs that the universe is shaped. A web needs open space to be a web. A constellation of great structures needs room between them in order to become a pattern at all. The silence is not outside the music. It is part of the music. That idea has a way of changing how emptiness feels. In ordinary life, emptiness is often treated as something uncomfortable. An empty room can feel lonely. An empty schedule can feel strange. A pause in conversation can feel awkward. A blank page can feel intimidating. We are used to density. We are used to things filling the frame. So when we encounter emptiness, our first instinct is often to see it as a lack. But the universe does not seem to think that way. On the largest scales, emptiness is not just tolerated. It dominates. It defines. It creates contrast. It gives structure its shape. The great galaxy clusters matter because of the immense darkness around them. The filaments matter because of the hollows they span. The visible cosmos is legible because there is so much open room between its brighter parts. So perhaps emptiness, at least in this cosmic sense, is not the opposite of meaning. Perhaps it is one of the ways meaning becomes visible. There is something deeply restful in that. It suggests that not every quiet space needs to be filled. Not every blankness needs to be corrected. Not every pause is a problem. Sometimes room is what allows a pattern to breathe. Sometimes silence is what makes the structure clearer. Sometimes what looks empty at first is simply spacious in a way the mind has not yet learned to appreciate. That is what cosmic scale does to us when we sit with it long enough. It stretches our emotional vocabulary. It makes room feel less like absence and more like a condition of beauty. And maybe that is why the universe becomes so calming when approached slowly. Because it does not merely overwhelm us with size. It teaches us another relationship to scale, another relationship to silence, another relationship to what counts as enough. The truth is, the universe does not seem hurried. That may sound obvious, but it is worth saying out loud. Everything we have talked about in this journey, the growth of the cosmic web, the gathering of matter into clusters, the widening of voids, the movement of galaxies along filaments, the passage of light across tens of millions of years, all of it belongs to a reality so patient that patience itself begins to feel like a law of nature. Nothing rushes. Nothing hurries to become complete. The universe allows whole structures to emerge over billions of years. It allows emptiness to deepen slowly. It allows the web to stretch and the quiet places to widen. It is not in a rush to fill every corner. It is not in a rush to make itself obvious. That too has meaning. Because we live, most of the time, at the opposite end of that rhythm. Human life is quick. Thoughts move quickly. Worries arrive quickly. Days pass quickly. Even our technology speeds up our sense of expectation. Messages, answers, decisions, reactions. We become used to compression, speed, and immediacy. So when we look into the large-scale universe, we are not just looking into distance. We are looking into a different tempo of being. A slower one, a deeper one, a quieter one. And the space between galaxy clusters may be one of the purest expressions of that cosmic tempo. It is not just large. It is slow. It is so large that its size can only really be described through time. Light itself takes ages to cross it. Meaning unfolds there only when the mind is willing to slow down enough to feel what millions of years actually imply. This is why the emptiness between clusters feels almost meditative when imagined properly. It pulls thought out of the nervous rhythms of daily life and places it inside a frame where almost everything urgent becomes local, temporary, and small. Not meaningless, just small. And small is not an insult. Small can be intimate. Small can be precious. A cup of tea is small. A sleeping child is small. A whispered conversation is small. A lamp in a dark room is small. The earth is small in the cosmos, but that does not make it unimportant. It makes it delicate, rare, specific. The same is true of us. Learning the scale of emptiness does not reduce human life to nothing. It places it more carefully. It reminds us that we are not the measure of all things, but we are part of a reality so much larger than ourselves that even understanding a little of it becomes a kind of grace. There is another layer to the meaning of cosmic emptiness, and it has to do with humility. Not the harsh kind of humility that crushes the self, but the softer kind that loosens it. The kind that helps us stop mistaking the familiar for the final. Because the more we learn about the universe, the more it resists our ordinary instincts. We imagine fullness. It gives us vast sparse structure. We imagine bright objects as the main story. It reveals invisible scaffolding and huge quiet gaps. We imagine emptiness as trivial. It turns out to be central. Again and again, the universe gently corrects us. And perhaps that correction is one of the healthiest things science can offer. It teaches us that reality is not obligated to resemble our habits of thought. That can be disorienting at first, but over time it becomes liberating. Because once the universe stops needing to fit our emotional assumptions, we can admire it more honestly. We can let it be strange. We can let it be subtle. We can let it be mostly dark and still find it beautiful. That last part matters. Beauty does not require density. Beauty does not require noise. Beauty does not require endless activity. A snowfield at night can be beautiful because it is quiet. A desert can be beautiful because it is open. A clear winter sky can be beautiful because it is spare. The universe, on its largest scales, seems to follow that same principle. Its beauty is not only in what it contains, it is also in what it leaves open. And the spaces between galaxy clusters are perhaps the greatest openings of all. They are the enormous intervals that keep the cosmic web from collapsing into clutter. They are the great silences that allow the bright structures to stand out. They are the room in which the universe arranged its largest visible forms. Sometimes, when people think about space, they imagine it as an endless container waiting to be filled. But after this journey, perhaps it feels more accurate to think of it differently. Not as a box with objects inside it, but as a relationship between concentration and openness. The galaxies, clusters, and filaments are the concentrated nodes. The voids and vast intercluster distances are the rests between them. Together, they form the composition. And what a strange composition it is. One in which the rests are longer than the nodes. One in which the quiet occupies more volume than the music. One in which the emptiest looking places are not accidental pauses, but essential parts of the whole. There is comfort in that, especially for a restless mind. Because so much of human discomfort comes from the feeling that quiet must be filled, that stillness must be justified, that emptiness must be corrected. But the universe offers another possibility. It suggests that spaciousness can be meaningful on its own, that a pause can belong, that a vast silent interval can be part of a larger design without needing to become something else. If this slow final stretch of the journey is helping you relax, you can gently leave a like, subscribe if you'd like more calm explorations like this one, and maybe leave a comment sharing where in the world you're listening from tonight. It is always a soothing thought that while the universe is immeasurably vast, moments of quiet attention can still connect people across one small planet. There is also something else the emptiness between clusters reveals, something almost tender in its own strange way. It reveals that existence is not only about what gathers, it is also about what separates. We tend to focus on things that come together. Stars into galaxies, galaxies into clusters, matter into structure. But the universe is equally shaped by what does not gather, by what thins out, by what opens. The wide regions between clusters are not just the opposite of formation. They are part of formation. Without low-density regions, there would be no contrast, no web, no visible hierarchy of structure. The places where matter did not collect as strongly are part of why the places where it did collect became so legible. This is one of those truths that feels scientific on the surface and personal underneath. Because human life, too, is shaped not only by what it contains, but by the spaces around things. Relationships need distance as well as closeness. Music needs silence as well as sound. Thought needs pauses as well as words. Sleep itself is not an interruption of life. It is part of life's rhythm. Rest is not wasted time. It is one of the conditions that make wakefulness possible. Seen that way, the universe begins to feel strangely familiar, not because it mirrors our daily life directly, but because the same deeper principle keeps appearing. Structure needs room. Meaning needs spacing. Light needs dark. A web needs hollows. And maybe a mind needs silence now and then, not as absence, but as structure. That may be the most calming lesson hidden in all this cosmic scale. The emptiness does not threaten the pattern. It supports it. And then there is one final thought, perhaps the quietest one of all. The universe is old enough, large enough, and patient enough that it did not need to fill itself completely to be complete. Just let that rest in the mind for a moment. It did not need to fill itself completely to be complete. There is something incredibly peaceful about that. The idea that completeness does not require density. That wholeness does not require crowding. That a reality can be mostly open, mostly silent, mostly dark, and still be full in the deeper sense, full of order, full of history, full of structure, full of possibility. That is not how we often speak to ourselves. We often imagine we must fill every gap, answer every question, solve every concern, become more, do more, say more, hold more. But the universe itself does not seem to obey that law. Its greatest structures are suspended inside enormous spaciousness. Its architecture depends on things being left open. And that thought, more than almost anything else in cosmology, has a way of softening the grip of the day. Because if the universe can be mostly silence and still be meaningful, then perhaps not every silence in life is empty either. If the universe can leave such immense room between its brightest gatherings and still remain beautiful, then perhaps spaciousness is not something to fear. Perhaps rest is not a lack. Perhaps stillness is not wasted. Perhaps the room between things is part of what makes things real. When you look up at the night sky after thinking about all this, the darkness may never look the same again. It will no longer seem like a simple backdrop for stars. It will feel layered. The stars belong to one scale. The galaxies belong to another. The clusters to another. The web to another still. And beyond every bright point, between every larger structure, there are intervals of staggering size, open rooms in the architecture of reality, places where matter grew thin and silence became immense. The velvet, not just the diamonds. The pause, not just the note. The room, not just the walls. That is what the true scale of the space between galaxy clusters finally teaches us. That the universe is not mostly a crowded gallery of shining things. It is a delicate arrangement of brightness suspended inside almost unimaginable spaciousness. The lights are precious because the darkness is so large. The gatherings matter because the separation is so profound. The web is beautiful because its hollows are so vast. And that is not a sad thought. It is a deep one, a soft one, a restful one. So now, as this long journey begins to come to an end, let everything widen one last time. Picture the Milky Way, one quiet spiral among many. Picture the local group, our small galactic family. Picture the great clusters, those immense cities of gravity. Picture the filaments stretching between them like faint cosmic roads. Picture the vast voids opening wider than any human instinct can easily hold. Picture the light taking millions upon millions of years to cross the spaces between the giants. And then, more gently still, picture the whole thing as one enormous web suspended over an ocean of almost nothing, a universe whose greatest lesson may be that emptiness is not the end of meaning, but one of its grandest forms. If you've stayed with me all the way to this quiet edge of the cosmos, thank you. And if this kind of slow journey helps you rest, helps you think, or helps you drift into sleep, you're always welcome to come back for another one. For now, let the clusters drift far apart again. Let the filaments fade into the distance. Let the great dark spaces open softly in every direction. And let the mind do what the universe itself has done for billions of years. Not rush. Not fill every corner. Just rest in the vast, patient, beautiful room between things.